So, good morning, everybody. Welcome to PROFES 2021 in Turin, Italy. Unfortunately, this year, as last year, we have to do the conference in a virtual setting. But last year, we were already very successful with it, and we hope to repeat this time. On behalf of the General Chair and the Program Chairs, I'm here to welcome you to the PROFES conference with some introduction notes. So the first thing I want to talk about is some data for PROFES 2021. So in total, we had 36 submissions. Each paper was reviewed by 3 reviewers. The acceptance rate is 39%, which means that in the end we have 14 full papers accepted, which you will hear today. We had in total 210 reviews and 3 external reviewers, which you will see later on. If you look a little bit at the submissions and acceptance rates, I made a very short analysis to which extent, for example, the acceptance rate has a correlation to the number of PC members per country. You see it on the right side, lower right side. And even if Germany, for example, has 12 PC members and Italy 13, the number of accepted papers for Germany and Italy is not higher than for other countries. So the number of PC members does not have an influence there. In general, I think we have a quite good mixture, but in regard to the countries and the participation in our conference. So PROFES, starting as a European conference in 1999, is really now, after more than 20 years, an international conference with an audience from all over the world. So in my next slide, I will emphasize a little bit more on what is PROFES about. So it was funded as a conference on software process improvement, and in particular, checking out to which extent activities in the process have an influence on product quality. And if we look into the key phrases analyzed in EasyChair, we will find that software engineering is the most mentioned topic for sure. Then we have software development, agile development, federated learning was also submitted, but you see here that in the end, federated learning did not make it into the final program. So that's the top 10 of phrases. And some other phrases were also not, let's say, considered more important enough by the reviewers in context of the papers. So it's really showing the clear emphasis of the conference on software engineering, agile development, and the life cycle. So we are really a software engineering conference and not so much the machine learning conference. Regarding the program committee, you will find the names all also on the on our website. We have the external reviewers, and please give a great virtual applause to the reviewers, because they have to do a really tough job in a short time, read the papers, give their comments, discuss on, let's say, papers where we have differences in the ratings, and in the end come up with a meaningful and valuable program for all the people. So it's a service to the community, and thank you very much to our program committee members. Yeah, so for today, you will have 4 sessions. One is on agile and migration. One is on requirements and models. One is on human factors, and one is on software quality. And you also have the online proceedings available. You see the link. I'm sure you will have the link also in a second in the chat somewhere, so you can click it. I would hope that you enjoy the day with us. I would encourage you to participate in discussions after the talks. You have to log into YouTube, but then you can chat with the authors, and they will be happy to answer your questions. And also we have a Twitter channel. Please there use the hashtag PROFES 2021. So, and then finally, I would also like to welcome you on our conference webpage, where you find also future conferences. The next one will be in Finland. Further information will be provided soon. So the last words from my side is to thank very much also Marco Torchiano, so my program co-chair, and also the whole organization team in Turin. And therefore, I will now hand over to Marco to introduce our keynote. Thank you very much for your attention and have fun.
sensors and cameras. There are so many devices. We analyze all of them, but we couldn't use almost any of them because we are talking about an historical building where you cannot measure anything. You can put something, but very limited. So you understand that all these elements make this kind of application really, moving towards those major dimensions. When I was reflecting on the software that is the traditional context of this conference, indeed we are not talking about an ecosystem development because we are not talking from agile to DevOps, but we are talking about leveraging the design decisions. We also need that the traditional system we are not thinking about, yes, we want stability, understanding at the moment. First of all, we need to be also be very honest. We cannot go back. Idea that this not optimize software. ICT 2004. It's a very interesting area that But you should see the microphone level also. Okay. Yes. Now they should be able to hear also from home. Okay.
Prova. Si sente? Ok.
Okay, we are going to start back. Sorry for the delay, but we had some problem with the connection. So we can start with the next session.
Good morning, everybody. My name is Antonio Vetro. I'm chairing this session on migrations and agile. So 2 topics in this session. The first paper will be presented by Giuseppe Scaniello, implications on the migration from Ionic to Android. And please, Giuseppe. Okay. Can I start now? Okay. Thank you for coming. I come from University of Basilicata, and it is a small university in the south of Italy. It is quite far from here, and the climate is almost different. In any case, I present today some results from our long-term investigation on the migration from app implemented using Ionic to a native framework as Android. You know that when you would like to implement an app, you have to decide the native framework for which you are interested to deploy the app. On that slide, you can see 4 of the most important framework. Maybe only 2 are worth to be mentioned, Android and iOS. But with respect to this solution, we have also other solutions that are hybrid. So it means that you can develop a single application and then develop that application to different platforms. Among the different solutions that we have on the market, open source and commercial market, one of the most used is Ionic. This is widely used because it's open source, and its look and feel is not far from the look and feel of a native app. In addition, this kind of technology also supports the invocation of API of native functionality from the framework where the app runs. In the 2019, we have presented PROFES, an approach to migrate app developed using Ionic and Cordoba and Angular toward Android. And we have also observed a number of results of outcome from this migration, but we have the main goal to have implemented to have defined this approach and some of the supporting tools that allow the migration from Ionic to Android was that we observed in the market that, especially because we mining some message from Stack Overflow, that many of the developer first decide to implement apps using Ionic or other kind of cross-platform solution, and then once that they get feedback from the end users, decide to migrate this application or engineer this application toward a native framework like Ionic or iOS. To that end, we have defined in the paper that you can read in the proceedings a main research question that you can see here on that slide. And in particular, we are interested to understand from both the end user and developers the impact of the migration from Ionic to Android. To that end, we have designed and implemented two empirical studies. In particular, we have conducted an user study with the possible end users of both the source application and the migrated one, and a controlled experiment with developers. About the user study, the main goal was to observe possible difference in the user experience and the affective reaction of the end users. We involved 18 peoples with different background. Some of them had some experience in computer science, while other one did not have a complete background based on that field. On that slide, on the other hand, we can see the main aspect of the design of our user study. Particularly, we had two independent variables: technology, of course, Android and Ionic. And since we used a factorial design, each user was administered with both the version of the same application, the first one and the migrated one. And we considered a number of dependent variables. 4 was for assessing the affective reaction. To that end, we used the self-assessment mannequin, that is a tool widely used to assess the affective reaction of end users, and also use end user experience questionnaire, and that is based on 6 different dimensions on which we elaborate more in the next of my presentation. On the other hand, we conducted a controlled experiment with 39 students at the University of Salerno. They had specific skill on development of both Android and cross-platform solution, and specifically on Ionic framework. The average year of these participants in the controlled experiment is 24, and the larger part were men, and only a few was women. That is almost typical in Italy. We have an overrepresentation of men in our courses. Here we have, in that case, we use a different kind of design, one factor to treatment. So each participant in the experiment used as experimental object the source code of the original application or the migrated one. On that source code, the participants were asked to comprehend some part of the source code, to identify fault in the source code, and fixing, if they were able to, that bugs in the source code. In addition to these dependent variable, we also asked the participant to express their sentiment, their affective reaction, using the same mannequin as we did in the end user study. So we asked, for example, about the task on the comprehension of the source code, what is our level of pleasure, arousal dominance, and liking. That is another dimension that we have added as it is typical in the literature. We observed that from the end user study that the greater part of the participant appreciate much more, significant more, the version of the application implemented in Android or better. The application we obtained migrating the Ionic version of the app to using our migration approach to Android. We can postulate that this result was based on the fact that the cross-platform version of the app was less reactive when using it. We also observed that from the controlled experiment that there is not a significant difference about comprehension, correctness of fault identification, and the other dependent variable we have considered. This means that more or less the developer did not find a huge difference when conducting these tasks on both the version of the same app. A further possible implication from the researcher perspective is related to, and based on the achieved results, if it is viable or not to define new migration approach or customize our migration approach to different source and target technologies. For example, Titanium or iOS or React Native or PhoneGap that are three other technologies very used in the cross-app development context. Another point coming from our long-term empirical investigation is better to migrate or to re-engineer the application implemented use cross-platform solution. Our preliminary results suggest to work on the migration, but the researcher could also investigate if re-engineering is better there. We obviously focused on a specific kind of application, so this limits our generalizability. And then we use Movie App, that is an app we downloaded from GitHub that allows to perform some query on movie that are inside the database of the app. To conclude, from another implication from the researcher and practitioner is that it seems that migration is a viable solution for moving from a cross-platform to a native platform. And it seems that our findings, our preliminary findings, justify for future study on that matter. Also, the practitioner could be interested in that because the practitioner could use our solution to attack the market. So it could decide to implement a preliminary version of an app, get feedback on the end user, and then decide to migrate to a new to the native framework. This is my outline of, if you have any questions, I'm here, more or less on time.
Yes, perfect time. Thanks a lot, Giuseppe. My first reaction would be, given the keynote from Henry Muccini, maybe in the future, one reasons for migrating or not migrating would be energy efficiency. Who knows?
Actually, just before my talk, I chat with Henry, and I highlighted the fact that a few years ago, we approached a research project that then it was concluded shortly because maybe there was not sensibility from researcher at that time, and we decided to migrate a robot simulator that move on the map from a typical architecture, CPU-based, from a GPU architecture. We have a couple of papers on the topics, and we observed that the migration to the GPU was actually viable because we were able to reduce some energy, to reduce energy waste from that point. So, of course, energy is one of the most important aspects also to be considered in the migration, and not only because we are hosted in energy center here in Italy.
Right. Do we have questions from remote? Because I don't see here. No? One very short from here. Yes, there is a quick question.
So is the transformation totally automated, 100%, or you need to put your hand back into the generated code?
Actually, we have defined a number of guidelines to support the developer from the migration to the target, to the source to the target technology. There are some tools. We have developed some tools to support many of these guidelines, many of these steps of the process, of the migration process, but it is needed, since it is a very complex task, it is not possible to automate all the migration process, maybe using machine learning algorithms.
And what about generalizability? Indeed, not of the transformation, of the approach, of the process, I mean.
The general approach, I think that can be used also in different frameworks, but each cross-platform technology has some peculiarities that you have to consider in the migration, and also the target technology has some peculiarity because Android is completely different from iOS. So the meta process is can be used in a general fashion, but you have to customize many of the steps. So the industry can be interested in that only in case they advise the opportunity to migrate from one solution to one framework to another one.
Okay, I see no other questions. Thanks a lot, Giuseppe, for your presentation. Thank you. So, second presentation, the migration journey towards microservices. Paper from Ayas, Leitner, and Hebig. Please apologize if my pronunciation was totally wrong. And will be presented by... Perfect, the first author. Here we are. Thanks for the patience.
So thank you very much for setting up and for the short introduction. My name is Hamdi Michael Ayas, and I did this work with collaboration with Philip Leitner and Regina Hibig, and I am going to talk about our paper on the migration journey towards microservices. And basically, yeah, I will discuss a little bit of how the journey is equally or even more important than the outcome of finally migrating to microservices. So microservices-based architectures is basically a type of service-oriented architectures that helps in developing software into individually bounded pieces of software. So features and functionality that have their own data sources, databases, infrastructure to set up and deploy and so on and so forth. So as software, as software grows, they become difficult to maintain and to update in time and to have fast features releases and so on. So they need to be restructured, and then microservices is a potential way to do it. So imagine that you are a product owner and you have a piece of software that grows and grows and becomes, as we said, difficult to maintain and manage. And then once you research the internet on different ways to structure the software, you will see microservices, and that's a potential way to do it and has many benefits with scalability, maintainability, and so on and so forth. However, to get once you start migrating, you will figure out many challenges and difficulties. So for one, changing the architecture of any software is complex and is complicated and difficult in general. It needs a lot of time and it needs a lot of things to change. Also, migration processes are not always defined, structured in a structured way, and migrations take place often in an ad hoc manner. Organizations try and fail and try again and so on. And also a lot of knowledge out there, they have to do with either architectural patterns that are a bit general or operational activities that are more specific, for example, how to deploy and so on. So there's a bit of difference of the frame of mind that of the knowledge that is there. So the objectives of this study is to, first of all, organize the migrations in a process. So the different aspects that describe past migrations from those that we investigated. So we do this by aggregating together a migration journey with different activities, and we demonstrate a little bit the eventual nature of migrations in organizations. So to achieve these objectives, we ask the research question of what is the migration journey that companies go through when transitioning towards microservices. So on what different levels can the migration journey take place on, and what do those different levels entail? So what are inside? To answer the research questions, we went out there and we interviewed 19 engineers that come from 16 different organizations and have 6 different countries and have a variety of experience level. So we have from junior developers to CTOs of medium-sized corporations in different business domains, from enterprise software to aviation industry, software for banking, telecom, and other industries as well. In our results, first of all, we see that the migration journeys take place in basically 2 different modes of change. So we have first a long-term journey, so a long-term architectural journey, which has to do with the architectural changes. And then we have a shorter-term system journey, so how the system or more technical artifacts change. And we observe 4 recurring phases in these modes of change. First of all, making design decisions. So organizations had to do some design decisions on how to move forward. Then we have the phase of altering the system actually, so actually changing stuff. And then we had the phase of setting up supporting artifacts that come along with microservices and implementing additional tech that is required. We had 18 different activities in total. Due to time, they are all in the paper. We cannot cover all of them, but an example, for example, in the architectural level migration and on the phase of altering the system, we observed that organizations, first of all, they had to do the activity of building a shell API around the monolith, then extracting one service and discussing what the first split should be, and then define the granularity of different services and extract more services. So that's more of an architectural level change that takes place. And an example in the system level migration, so in the final phase of implementing additional technical artifacts, the organizations had to further develop some things like communication and orchestration tools, or the monitoring and logging, which is in microservices is different and needs different new development there, and new ways of handling reused artifacts using libraries, APIs, or whatever the organizations choose. So this led to some implications to the teams. And the first implication is the diverse skills that engineers require to have when have these migrations. These journeys, they reveal different types of activities, and then engineers needed at least to be aware of some of them and be specialized in some of them. So the diverse skills is required. It's not enough to just have one skill set. And another implication is that we observe that the complexity of the development shifts from the development of the software to communicating between microservices. So there is a lot of complexity that is no longer in the code, but on the communication aspects of different microservices. So, and our aggregated process and activities, we have some two main small contributions, and one of them is that we view migrations as a continuous improvement initiative rather than just a one-off project. So this could be either because the migrations take a long time and they have a lot of change, or because often migrations are a sideline activity of engineers that they do in parallel with developing the software further. And the second contribution is basically providing an understanding of the process of migrating and having a topology and a little bit of what activities should we expect when we start a change or a migration in these different modes of change. So in summary, we have different modes of change that have different pace and different scope in time. We have a bridging between more architectural and more operational activities and different steps that we can take along the way. So thank you very much for listening to me. And
thanks a lot, Hamdi. Questions from the room or from the virtual room? Please, Harry.
So we are also working on migration to microservices, and what we are doing is driven by quality attributes. So defining which qualities you want to improve and trying to get a process that drives you to get not only coupling and cohesion, but I don't know, better performance or better. In your set of interview, the question is, did you find anybody? I know that the focus was not this one, but I'm curious to see if anybody was focusing on this quality-driven process. I mean, if they had some quality metrics in mind that they wanted to optimize moving from the monolith to the microservice. And if so, if you have any input on this specific aspect. Thank you.
Yeah, thank you very much. I think that's a very good question because it touches upon a teleological way of change, which is based on the end goal and what is the objective. So to answer, yes, some of the interviewees, they had some quality attributes in mind, but I think there is a difference of what was meant by quality. So some of them had, of course, some performance issues, like the application became too slow or too bulky, and others had the more organizational or structural issues. So it's both. They both objected to improve the quality in some way, in different ways. And of course, there were some that basically they were in a deadlock of, in a panic mode, if I may say, that things really needed to change, and because it was becoming impossible to develop further. So there were some teleological, at least initially, some of them mentioned developing a business case with cost improvement goals. So at least initially, I think many of them had, but in the process, they realized, at least from what they said, most of them, that it's a bit bigger than just improving a number, because maybe we need some more investment to do, maybe some more changes that will cost more. So I would say in the beginning, many of them had a more teleological approach, but in the process, this changed.
There's another question over there.
What would be your advice when one of us meets such a situation, doing an migration or re-engineering the system, since some development decisions could be different when you choose one architecture or another?
Yeah, I think that's, again, a very valid question, and one that at least all the organizations I spoke with, they did in the beginning. And I think it depends on your domain and your software. So some of them, it was impossible for them to just disregard the previous. For example, I mentioned we spoke with banking industry, and then they had these very old systems developed since the 80s. But it's so crucial that they basically didn't have the choice. They just have to migrate. And so my advice would be, depending on the domain, maybe that's too diplomatic advice, but both of them have values, both of them have trade-offs, and I think it depends on the team, on the domain, on the software that is there.
Thanks a lot. Thanks again for your presentation. It is now time to migrate from academia to industry. We have an industry paper, migrating from a centralized data warehouse to a decentralized data platform architecture. Reading the surnames is very challenging for me, so I will leave to the presenter.
Okay, thank you.
Thanks a lot.
So it's Antti Loukiala. Yes. So it's actually very nice to follow up on the microservices presentation, because this is kind of follow up on that in many ways. The topic is migrating from a centralized data warehouse to a decentralized data platform architecture. There's also the fellow writers who were involved in this. So just a brief outline. I will talk about the background and the challenges, why this is such an important topic to actually tackle. Then I will touch upon the decentralized data platform, the concept of how to actually start tackling those problems, and then finally some conclusions on it. A bit of a background. So we'll jump now into the field of data and data warehousing. So I guess you could consider it as maybe a different field in software engineering or another domain, whatever you want to call it. But the role of data in companies, it's ever increasing. So if you think about what digitalization is doing for companies, the data is becoming more and more central to the way we develop software, the way we understand the business that we are in. Now you have these applications that are based on data. So they're built on data. So actually the data might be actually born outside of the application which we're new building. So you end up with these data intensive applications and such. And with this sort of evolution, the data is required to be available from all over the company. So if maybe before it was more for financial purposes where you needed a data warehouse or data in general, nowadays you actually need it from every single application from your company to be available. Like we heard in the keynote, you need data to understand how people move in the museum and when are they coming in, how long time do they spend there. So the data actually has to be collected from a wide variety of systems. And many existing solutions that are solving this gathering of data, it's usually by integrating data into a central warehouse or a central data lake. And that's sort of the traditional way of doing it. So what happens is that data is extracted from the source systems, then it's curated into a needed format, integrated into with the different data sets, and then typically modeled in a dimensional model. And because of this nature, you end up having a centralized system. And data lake, which is a bit newer concept, usually built on top of object storage, it's also a good way to store raw data. So when we talk about images and such, whereas data warehouse is usually or most often a relational database, the data lake can offer like new advantages to accommodate the data warehouse. But still, the data lake is usually built in a centralized manner. And so this leads into the challenges. So this current centralized way of working with data, it starts to form a monolithic system, like we heard in the previous presentation. So with the centralized system, it's of course, the monolithic system, it has certain like characteristics, regardless whether we talk about centralized monolithic data system or software system or integration system. It doesn't escape the same characteristics. And I would say that even on top of what you have in a software monolithic data system, the more challenges that come from the data side is now that we are integrating data from multiple systems into one, you actually have to know the data that you're integrating. So you have to know the source system, the domain of the source system, where it's coming from, and all of the details in that central team. So it adds like this additional level of complexity in a form of a domain knowledge. And also now that you're actually pulling all this information into one, the data model that you're building, it's also becoming more complex as more and more data is integrated. So even though the modern data engineering practices are, you can have automated metadata-driven data warehouse development. The data warehouses are, massive parallel processing, cloud-based, extremely powerful data warehouses. They're still managed in a central way. So even with these improvements of making things faster, we still are in the same idea of having everything central. So in an essence, if you want to like condensed, as this is from experiences from an industry, how do you scale a data development when you have hundreds, if not thousands of source systems? How do you do that centrally by one single team? It becomes, I would say, impossible. So how do you go about scaling? Well, we just heard pieces of the answer. So of course, the problem of scaling a monolithic solution is not new in the software development. So for example, microservice architecture answers the question of scaling. And I think it's good to keep in mind here, we're talking about scaling a system. We're talking about multiple source systems where we have to get the data in order to become more data driven. And of course, the microservices emphasizes the decentralized, distributed, and independent services. So with the loose coupling, it allows you to do independent, continuous deployment, regardless of each service. And the domain-driven design and the concept of bounded context is very helpful here to understand which would be the services that you want to break into the different pieces. So in other words, so if this representation here is a central data solution where you have the sources at the bottom, now you could have hundreds of different sources, but the white circle in the middle would be the central solution where you ingest the data, you store the data, you transform that into a publishable format. You create views or sort of dimensional structure on top of it, which allows you to do easy data sort of interaction in a very easy format, and then you use it for whatever purpose you do. For example, reporting tools, dashboards, applications, what have you. So how do you go about breaking this into parts? Well, you can actually do so that each one of the source systems is ingested, stored, published, and created an interaction separate of each other. Nothing is sort of contradicting this. And then if you break them into pieces, well, you start to look something that looks like a microservices in the field of data. This actually allows you to do independent deployments, independent maintenance. You can have a team working on each one of these data pipelines, as we call them, independent of each other. And this allows you to scale. So now if you look at this from a different perspective, the black dot, the big black dot represents a source system. Of course, in a domain, you can have one or multiple, but just for the simplicity, we have one. And now these teams are actually creating different kind of data sets for others to consume. These others that you're consuming, of course, they have to match the standardized format and have to be very interoperable in order for you to use them. And then the role of IT also becomes, I would say, clearer, because now they are providing technology for these different business domains to solve their problem, instead of IT solving the problems for the business domain. So the transition is a small one, but I think it has a huge implications. So the conclusion. In the paper, we propose a decentralized data management architecture to improve scaling of data development based on experiences we had from a large Nordic manufacturing company. In the paper, we introduced the existing architecture, what were the drivers for change, and what are the reasons sort of behind this, and also giving indications of why it actually worked. And also, of course, we introduced the new architecture. So sort of the principle here is the centralized data platforms can stop scaling at a certain point when organization domains are large. So we're talking about hundreds, if not thousands of systems. It's very heterogeneous. So like mentioned, you have legacy applications, new applications, and everything in between. And it's non-flexible by nature. So at that, it stops scaling, and then you have to look for new ways of doing it. And this decentralized data management is one of them. Thank you.
Thanks a lot to Hamdi Loukiala. I hope I pronounced it correctly.
Yes.
And one question: is the proposed architecture agnostic of the type of data source? Can be a device or even a local, let's say, data lake or a local data warehouse?
Yes. in an essence, it's not so much about technology. It's more about organizing around the sort of the problem and where are the developers and so on. Like was mentioned before, that it's more about having cross-functional teams going next to the business instead of staying in IT and starting to solve it. So whether you're doing it locally or in the cloud or data lake or data warehouse, it doesn't really matter. It's more about going next to the business, solving the business case there, and everything sort of around does support that. So we went through like technology barriers. That is, there's something stopping. Is the technology stopping us from doing this? And we couldn't find anything. So in that sense,
questions from the room? Yes, there is one question.
Yeah. So my question is, in the last slide you mentioned that there is a limit, and then things don't scale any longer. What do you think is the main reason or the biggest barrier of this happening?
That's a good question. I would say I can't state what's the limit, like what's the numbers, like how many systems and so on. But I think every time when if you think about like a data warehouse team, they usually get requirements from the business in order to get the data in and so on. And I think the indications of things not happening is that if the lead time starts to be months and so on, or simply the team is not able to do it and you have to scale it bigger, and all of a sudden the team is, if you have a large team, it's hard to communicate within the team. So that's also brings barriers. So I think these are like clear indications that system is not working and you have to start looking into scaling. And it's not uncommon that you hear, in a company that, as I work for Solida and going to different companies to discuss these things, you hear things that it takes 6 months, 8 months to get new data source into a data warehouse. So if you imagine the speed of change that is required at today, that's not enough. So you have to find ways to do it faster.
Thanks a lot.
Thanks a lot. And thanks again to Hamdi Lokliala. How do agile teams manage impediments? This is the title of the fourth paper by Sven Theobald and Pascal Guggenbiel. It is should be online presentation, if I'm not wrong. Yes.
Yes, hello everyone. My name is Sven Theobald and I'm with the Fraunhofer Institute for Experimental Software Engineering in Kaiserslautern, Germany. My colleague Pascal Guggenbiel and I conducted a survey study on how agile teams manage impediments. And I'm happy to share the results with you today. What is an impediment? An impediment is everything that prevents the team from reaching its goals and slowing down the progress of teams. So this could be very small blockers of the team, or also some large improvement goals that the team has to improve the way of working. The Scrum guy mentions impediments only in 2 places, namely that the Scrum Master causes the removal of impediments and that the daily Scrum is a mechanism to identify those impediments. But there is no further guidance on how to deal with those impediments. Related research mainly focused on identifying impediments and clustering them in different categories in order to better understand what problems agile teams face and how they can solve them. However, there is only few related work that actually deals with the process of identifying impediments, documenting them, and finally resolving them. So in a previous study, we conducted a few interviews to elicit from the participants how they identify impediments, how they document them, and finally how they resolve them. And based on the results, we created this model of the impediment management process. And this was also the base for our extension of this study in the way of a survey study. So in our survey study, we had the goal to identify how teams manage impediments in practice. So especially how they identify the impediments, how they document the impediments, and how they track and finally resolve the impediments. And based on this goal, we created a survey questionnaire based on the previous interview experiences, and we distributed the questionnaire in the form of an online survey among conference participants of the XP 2020 in the context of the on-site research track that wasn't on-site at this point of time already. After some time past the conference, we also created a copy of the survey and distributed it among some groups in business networks that related to Scrum, Agile, Scaled Agile, to reach as many participants as possible, as many Agile practitioners as possible. In our interview study, we focused on Agile software development practitioners. In our survey study, we opened that and said, okay, in general, everyone that handles impediments and somehow does some form of Agile is able to participate. And we had also some participants from hardware or just other teams that did not develop software. Now I want to share with you some insights regarding the results. So in our first phase of our impediment management process regarding the identification of impediments, we first wanted to know what is an impediment for you. So what is your understanding of an impediment? And we asked whether they rather see them as blockers that prevent the progress or rather some target improvement goal that they want to reach. And most participants there answered that they see impediments really as blockers. That is some obstacle that teams have to remove in order to work more efficiently in the future. Then we also asked about the size. Are impediments for you rather the small problems that arise maybe in the daily Scrum and can be fixed quite easily, or are these rather the larger problems that need more time to be resolved? And yeah, there are participants that claimed both of those situations. Then we asked, okay, what are the mechanisms to identify impediments? Where do you identify your impediments? And of course, like the Scrum Guide suggested, the daily Scrum or daily stand-up was mentioned by most participants as an opportunity to raise impediments, also with continuously raising impediments, for example, identifying them with the conversation with the Scrum Master. But as you can see, the other Scrum events like sprint planning, sprint review, and sprint retrospective, of course, are also mentioned quite often. Other mechanisms were cross-team meetings or status meetings with many stakeholders. In the next phase, we asked about how do you deal with them? Now you identified impediments, how do you document them? And in our previous interview study, we had participants mentioning that they only document the problems because they need to understand the root causes and they really need to fix the underlying problem. Other participants claimed, okay, we only document solutions because they are actionable and we need something that we can do in the next sprint, some concrete action points. And here our participants, most of them mentioned that they do actually both. So they link them together, the problems and the solutions. There were also some participants that reported that they only document the problem. And there were actually no participants that say, okay, we only document the solution and don't follow up on the problem anymore. The place where impediments are documented, it was quite well distributed among participants. So almost half of the responses claimed that they document the impediments in a separate backlog or list, like in an impediment backlog. And the other half of the participants roughly claims that they document impediments together with the user stories and tasks, for example, in a task board, or if there are larger impediments in a product backlog. Other options here were meeting protocols or just not documenting them at all because they were directly solved all the time. We also wanted to know whether participants estimate their impediments, so the effort to solve it, and most of them do not estimate their impediments. However, impediments are planned into the next sprint by most of the participants. In the final phase, the resolution of impediments, we asked them in 2 questions that are now combined in this graphic, which roles are responsible for tracking the impediments, so following up on the progress of resolving these impediments, and which roles are responsible for the actual resolution. And you can see that participants claim that the development team, together with the Scrum Master, work on both tracking and resolving the impediments. The biggest difference in both responsibilities can be seen in the place of the Scrum Master, where more participants claim that the Scrum Master helps to track those impediments, but is not actually always the person that has to resolve the impediment itself. I want to share 2 further questions that we asked our participants. So one was, does managing your impediment improve your team, provide benefits to your team? And most of the participants claimed that it's helpful. There are no participants that claimed it does absolutely not help me, but there were some of them that claimed they actually do not see the benefits or do not really know what the benefits are. And another question which might be interesting for further research is the questions in which of these 3 phases participants see the biggest potential for improvement. And although we can see that all phases get some mentions, so everywhere there are some problems, every team has individual problems or perceives the problems at this point of time individually, we can see that actually resolving the impediments was mentioned by most participants, and many of the free text answers explained that this is because agile teams have a lot of dependencies to external stakeholders and need the collaboration with those stakeholders to resolve the impediments, which delays the time to finally be able to resolve them. This was my overview of the results, and I'm happy to receive your questions now. Thank you for your attention.
Thanks a lot. Thanks a lot for your presentation. I don't see at the moment. Yes, there are a couple of questions from the physical room.
Hi, Giuseppe Scaniello speaking. Thank you for your presentation. I don't remember if XP 2020 was online, hybrid, or something like that. Was hybrid?
It was purely online.
Actually, you got a very huge number of answer from the attendee of XP 2020. Research on site is a very interesting track for XP, and it seems that it's becoming the standard also for other kind of conferences. In the past, I have also the chance to apply for that track. Unfortunately, we did not get a huge number of answers from the audience, while you got a very huge number. So my question was, why you used only 17 answers from that attendee of XP and not all the 40 and I don't know how many? Thank you.
Yes.
And of course, if these affected in some way the results of your study, if you believe in which way that affected the results of your study.
Yes, thank you for your question. So I have echo. Can you? Hello, test. Thank you. So it was the on-site research track, but it was just the start of the COVID-19, so they had to change it to an online format. And we initially thought to conduct in-person interviews, but had to change to an online questionnaire, an online survey. And we created a video motivating the study with the link, and I try to publish it in some channels and mention it to participants. And of course, like in every online survey, many participants access the questionnaire and start looking at it, but do not always follow through all the questions. And the questions that we used were the people that actually put more than only their demographic data there, because some just skipped everything, some just entered a few questions but did not follow up the full questionnaire. So we really only used the data which was valuable to analyze. We did not exclude any answers that we didn't like, so we have better research results or something like that. I see a question from the chat regarding the correlation between impediment management and risk management. And of course, there is a correlation, but it depends how you actually conduct your impediment management. So I think quite many agile teams only identify those blockers when they arise, and that's not risk management to look in the future. But there are also teams that added this aspect regularly to also look into the future. What could be the potential impediments that could appear at some point of time based on our current situation without that it's already the case. So I think risk management is just one step ahead in my opinion. And if you have further questions, you can always send me an email or we can talk about that. And I can give you some literature that also combines those two concepts in one life cycle, so to say.
Ben, thanks. And we now move to the last talk of this session. Will be a recorded video, but the authors will then connect it to answer live to the questions. Keeping the momentum, driving continuous improvement after the large-scale agile transformation by Josephine Boring and Maria Pasivara.
Have decided to make the transition to Agile. Often we see that organizations transition. Hello and welcome. I'm Josephine and I'm really excited to be here today to tell you about this research project I did with Maria Pasivara on Lean Agile Center of Excellence at Nordea. We call it Keeping the Momentum, Driving Continuous Improvement After the Large-Scale Agile Transformation. Let's begin. Agile software development has been getting increasingly popular in the recent years, and even large organizations have decided to make the transition to Agile. Often we see that organizations transition to Agile in the development organization, but without making changes to the systemic structures, underlying assumptions, or culture. In the most popular framework for scaling Agile, SAFe, this important task is carried out by a small group of people in what they call a Lean Agile Center of Excellence, or LACE. As you can see, the SAFE framework is extensive and describes roles and methods that is designed to help many teams working together. On the team level, SAFE draws on several well-known agile methodologies. Much like Scrum, teams have a backlog of work that is prioritized to maximize value delivery by a product owner, and teams deliver and improve regularly. Work shared between teams is coordinated in agile release trains consisting of several teams with additional roles and mechanisms to support coordination. Now, at the heart of agile development is continuous improvement, and in SAFE, continuous learning culture is a core competence. On the team, train, and solution levels, there are dedicated roles to facilitate process. Scrum Masters, release train engineers, and solution train engineers are tasked with facilitation and optimization of how their groups work, among other things. But who facilitates continuous improvement on the organizational level? One idea could be the LACE. According to the SAFE literature, the LACE is cross-functional and has credible people from various functional organizations. It serves as a focal point for activities during the transition to SAFE. More specifically, the tasks of the LACE are communicating the business need, urgency, and vision for change, developing the implementation plan and managing the transformation backlog, establishing the metrics, conducting or sourcing training for all, identifying value streams and helping define and launch agile release trains, and providing coaching and training. The question is, what happens to the LACE after the initial transition is over? According to SAFE, a LACE often evolves into a long-term center for continuous improvement. To investigate how this may look in practice, we've investigated one such LACE. The Nordea case is interesting because they've been practicing SAFE for several years and may help us see how a LACE can continue to drive improvement at the organizational level. Nordea is an international bank servicing household and corporate customers with nearly 200 years of history. They operate in 20 countries, employing 28,000 people. Nordea's SAFE adoption journey started in 2015, and they now have over 100 agile release trains with sites in several countries. To focus our research, we have asked 4 research questions. 1. How has the LACE changed over time? 2. How does the LACE work? 3. How does the LACE influence the organization? And 4. How can LACE improve to inspire and facilitate change? We base our research primarily on interviews. We interviewed LACE participants, all 3 product owners, and 2 people outside the LACE group. We asked the LACE participant about things like how did they hear about it, why they joined, what they've been working on and how they went about it, what challenges they've noticed, and how the LACE could improve. The product owners were questioned extensively about the history of the LACE, how it was established, how they prioritize and facilitate the LACE work. And people outside the LACE group were questioned about what they know about the LACE and how it affects them in their work. To observe what we could about the work here, we also took notes from 11 meetings, such as weekly meetings and work meetings. Regarding the first research question, how has the LACE changed over time? We find that the first LACE was much like it's described in the SAFE literature, a transformational closed forum consisting of coaches and line managers where practitioners were left out in favor of a top-down implementation. They dissolved after reaching their goals, and for a while there was no LACE, but it was reinstated by grassroots who made it into a big community of practitioners, inclusive for all willing to work on the changes they saw the need for. Having no dedicated resources and no formal mandate, they relied on goodwill to make changes. And while they had many volunteers, not much change happened because of the lack of focus and too many projects ongoing at the same time. The product owner who helped start the second iteration of the LACE explains the choice of open volunteer model like this. We were in a position at that point in time where we were cutting costs, cost conscious. And the plan was to show that the LACE can drive things, that it can implement systemic changes. And then from there, see if we could also get an allocation to drive more. And also personally, I like the model where you engage people and where everybody has a chance to be part of it. And it's not just the ones who are appointed to be part of the LACE. After the third PO joined the LACE, they realized that they needed to focus the work that they were doing, that the many volunteers working on whatever they saw fit wasn't implementing the changes they wanted. They decided to focus the work by implementing objective key results and limiting the work in progress to further the chance to make systemic changes. So how does it work? They've implemented an iterative process similar to that of a development team, which is a common reference point for everyone in the LACE. Product owners prioritize a backlog that anyone can add ideas to, and once every 3 months, backlog features are pulled into the next product increment according to the overall goals of that increment. The LACE meets once a week for a status type meeting, catching up on progress, discussing approaches, and solving any problems that might have occurred. Each feature is owned by a driver, and a small subgroup work to identify and implement changes as they see fit. Groups made for each feature depends on the knowledge and ability to implement the changes. It's unknown to us how many people participate in the subgroups due to the flexibility they have on the voluntary basis. Participants and product owners from many parts of the organization, both on the technical and the business side, makes the network of the LACE as a whole fairly large. Each subgroup decides their own approach to the target issue, often experimenting with smaller pilots to test out hypotheses before attempting to make larger implementations. This means that features are quite often in progress for longer than 1 3-month cycle. Multiple members of the LACE group has found that by communicating initial results rather than ideas, the peers are more susceptible to the solutions they present. The goals of the LACE vocalized by the interviewees are relentless improvement, improving across, and customer focus. These are represented in the objective key results of the LACE. When doing the first interviews, the voluntary basis of the LACE was revealed, which was surprising considering how it's described in the literature. So we wanted to investigate how this works in practice. How does the LACE influence the organization? Well, it turns out they work primarily through their network and goodwill, where participants work in groups with people from other parts of the organization and other roles to help implement the changes far and wide. While the LACE has a large network, however, some areas are not represented. So they host a business line-wide huddle to inspire and encourage their colleagues in other parts of the organization, showing off the results of recent pilots. Based on the feedback from interviews and our own observations, we've identified some areas of improvement. First of all, making the LACE more well-known by branding pilots as part of the LACE work will increase the awareness that LACE exists and hopefully lead to more people coming here to solve systemic issues they encounter. We also see potential in engaging the rest of the organization at an earlier stage, so people are more aware that they're welcome to join a team that's working to solve a challenge they're interested in. We also encourage the LACE team to introduce retrospectives among themselves. The LACE process mirrors the development process in all areas except this. LACE asked us for suggestions, but had plenty of ideas when we asked the participants. Lastly, because systemic changes don't happen overnight, the same feature stays in progress for a long time, giving the impression that not much is happening. It might take years to change some of the things the LACE is working on, but splitting up features makes it possible to monitor and show progress transparently. All right. Thank you so much for staying with me. That's all I have for you today, and now I'm ready for any questions you might have.
So we should have the authors connected.
Yeah, I'm here. Hello.
Online. Hello. Okay. How or if did you plan to continue this work for future work? What are your plans for future work?
Unfortunately, I'm working on another research project right now, but it would be interesting to investigate other LACEs to see how different this one is.
Okay, so at the moment, no plans for continuing the research.
Maybe one day.
Let me check a few seconds if questions come from the public in the physical room or the virtual room. And there are no questions. So we are a bit late with the program because of the technical issues we encountered. So thanks a lot, Josephine, for being with us and connecting to the conference. And I would like to announce that we will start the session 2 with 10 minutes delay, 5 minutes delay. And now it is time to have a short coffee break. Participants of the
Okay, so welcome everybody back to this second session of the PROFES2021 conference. This session is about requirements and models. The first talk will be by Yannick Fischbach, and it will be about how practitioners interpret the conditional in requirements. I leave the word to Yannick.
Yeah, hey guys. So let me share my screen. Can you see my screen?
Yes.
Perfect. All right. Yeah. Then hello from my side. I'm really happy to speak here. I want to present our most recent paper, which is basically the result of a collaboration between the BTH in Sweden, University of Cologne in Germany, and Quadicin, which is a startup founded of the Technical University of Munich. And the paper, which is entitled "How do practitioners interpret conditionals and requirements," was written by Julian, Daniel, Michael, Henning, Andreas, and me. And in this short presentation, I want to give you an overview of the motivation, of the background of the paper, the problem that we tackled in the paper, and also the contribution. So what can you actually find in our research paper? So the background is basically the whole area of requirements engineering. So if we think of function requirements that define the expected system behavior, then we can see often many conditional clauses in these function requirements. So for example, a conditional clause is something like here indicated on the slide, if A, then B. So you have two parts. A in this case is the antecedent and B is the consequent. And in order to implement requirements that contain conditional clauses, or also if we want to implement automatic methods that process requirements automatically, we need to logically interpret these conditionals because we need to understand what is the expected system behavior that is defined by the conditional clause. The problem here is, however, that we do not know how practitioners who implement and also write requirements interpret conditionals logically. So we do not know how we should formalize these conditional clauses and what is the impact of the logical interpretation of a conditional clause on implementation projects, on automatic methods, and so on. And in our paper, we address this research gap, and we report on a survey with around 104 practitioners, and we ask them about their logical interpretation of 12 different conditional clauses. So around about we got 1,000 answers here that I will analyze and explain the results to you. But I already want to conclude at the beginning of my presentation that conditionals are in fact a source of ambiguity, so that there is only one way to formalize them and to interpret them, because practitioners disagree on many aspects here. So that's definitely something that we need to consider in the future. From a practitioner's perspective, but also from the perspective from academia. So in our paper, we constructed a formalization matrix in order to differentiate between the different logical interpretations. And the matrix consists of 2 dimensions. So the first dimension is necessity. So I think we all know this from Boolean algebra. So the antecedent can only be sufficient, or also necessary for the consequence. So this has huge implication from a logical perspective. For example, if you want to write test cases for a requirement, so there's a difference whether the antecedent is only sufficient or also necessary. So we definitely analyze that here on this in this column. We also analyze the dimension of temporality. So we want to understand, when do practitioners actually expect the consequence to occur? So simultaneously with the antecedent, or maybe at some timestamp after the antecedent. So timing is also very important, right? So if we implement our systems, if we want to test them, so in this temporality dimension here can be seen in this very large column in our formalization matrix. And as you already can see in the matrix, we cannot simply use propositional logic here, because we also need to consider the temporal dimension, which means that we also need temporal logic in order to differentiate between these two different dimensions here. And in order to find out what is the mapping between the interpretation of a practitioner and the logical formalism here, we constructed or developed a questionnaire, and we asked the practitioner 2 different questions regarding the 12 different requirements. So the first question is about the dimension of necessity. And the second question is about the dimension of temporality. And after the practitioner selects an answer here, so for example, in this case, he selects AB and 2A, we map their answer, so the selection basically, to a cell in our formalization matrix in order to understand what does the practitioner implicitly mean. In this case, for example, the practitioner interprets the antecedent as also necessary for the consequence, so that's highlighted in the cell. And here he or she says, okay, the antecedent and the consequent occur simultaneously, which means that the logical interpretation in this case can be formalized by this cell. And we do that for all of our 12 sentences and map the different answers to heat maps, which can be seen on the left side here. And I just want to give you a short summary of our findings. Of course, feel free to have a look at our paper, because it's definitely in a more detailed way described there. One of our most relevant findings is that practitioners do not agree on whether an antecedent is only sufficient or also necessary for a consequent. So if you write a requirement and use a conditional clause, then some people might understand the antecedent as only sufficient, but maybe there are other people who interpret it as also necessary. So here we can see heat maps for all 12 sentences. And for example, in the case of sentence 4, I think that's a good example, 45 participants answered and said, okay, the antecedent is only sufficient, but a similar amount interpreted the requirement as also the antecedent as also necessary. So there's definitely no clear trend towards one of these necessity levels. We also found that time plays a major role, because it definitely matters whether you are using, for example, Q phrase like when or in case or after. So these Q phrases are related to different temporal interpretations here that can be also seen on the other slides. But I wanted to just give you here the impression that it is not possible to say we have a conditional clause and each conditional clause needs to be formalized in one way, because in some cases, you might use, can be used propositional logic. For example, in the case of sentence 2, here most of the people said that temporality is not relevant for the interpretation and the antecedent is only necessary. So you can use, for example, this formula. But in many, many other cases, for example, you need to use temporal logic. And these formulas can differ because also the interpretations differ, right? What was really interesting in our survey, that if we summarize or cluster the responses regarding the different Q phrases, then we can see that there are some Q phrases where practitioners agree on one temporality level. For example, in the case of while, which can be seen here below, the practitioners agree on that while typically, while can be interpreted with a during relationship. But if you use, for example, when or if, then the people do not agree on whether if or when, for example, define a during, a next state, or eventual relationship. So they do not really agree on one temporal relationship here, and that is from developer side and the tester side very critical, because in this case the people do not agree on a requirement, right? Because some people interpret it as during or next state eventually, and timing is very important here. On the right side, you can see the necessity level. So regardless of the usage of if, when, after, or while, the practitioners do not agree on necessary or sufficient. So that's it definitely underlines the findings of our heat maps on the previous slide. We also investigated some factors that might influence the logical interpretation of practitioners, and we found many different factors here. So please feel free to have a look at the paper. I just want to highlight two findings here. The first finding is that domain knowledge definitely impacts logical interpretations. So if you understand the system behavior that is described by a requirement, then your interpretation regarding necessity and temporality might be different to the logical interpretation of someone who does not know the system behavior that is described here. So that is one of our most important findings. Another finding is that the logical interpretation regarding temporality is to some degree dependent on how you actually interact with the requirement. So for example, a developer who implements a requirement might have another interpretation as someone who, for example, maintains or tests a requirement. So that was also very interesting. So let's sum up my talk. So what are basically the implications for practice and for academia? So in our paper, we present evidence that the assumption of many papers that are available in the community that an antecedent is always necessary for a consequent is not true. So practitioners do not agree here, is it only sufficient or also necessary? So for example, if we want to test a requirement or use some test case generation methods, then we always need to ask practitioners, what do you mean by the negative case? Do you think that this negative case is implicitly embedded into the conditional clause, because then the practitioner interpret the conditional clause, the antecedent is also necessary? Or what is your impression here? Or maybe some practitioners only think that the positive case is specified. So that's something that is very important here. We also should incorporate into our writing guidelines that it definitely matters which Q phrase is used. So do you use if or when or after in case? So we also want to do more studies here on more Q phrases. So it's definitely important that you agree on a stage. Sorry?
You are almost at your 10 minutes. Okay.
Just one sentence. And maybe you should also indicate an else statement here if you write a requirement in order to prevent the confusion about necessity. So sorry for that. That's it. And feel free to ask some questions.
Okay. Thank you very much. No, you were just a few seconds beyond your time. No worry. I wanted to ask you a couple of questions. Once before a clarification on your slides. In your slide 4, the horizontal dimension, I think is about the time dimension.
Yeah.
And the second question is, I've seen that you investigated 4 different connectors, if, while, after, and when. Did you also investigate or you have some insight or possible speculation concerning other kind of, say, elements such as logical connectors and or other kinds of this kind of additional connectors?
Yeah. So regarding the first question, you mean the formalization matrix here, right? Or what the question was about the temporality dimension, right?
Yes, it's on your slide 4, the heat map.
The heat map. Okay, you mean the heat map? Yeah, exactly. So that's the matrix here, and nevertheless is also something that we ask the participants for necessity, and during next state eventually, and irrelevant was for temporality. So for example, if someone says, okay, it is not relevant, then you can see all the answers here. And for sufficient necessary and nevertheless are basically the rows. But I mean, it's also very described in detail in the paper, because for us it was really important that we draw a mapping between logical interpretation and the formalization side. And for these cases, the heat maps are very nice to use here and easily to use, because can easily map the answers to a cell, right? Yeah. And towards the second question regarding the Q phrases, yeah, so far we only investigated if, when, after, and while. But so from it's a speculation, right? I don't have any evidence here, but I'm quite confident that other Q phrases might also be related to divergent interpretation. So I think while is quite easy, because while and during, so the during relationship and while is quite similar. But let us assume a sentence where you use in case, in the case of, and these words. I think these words are quite similar to after, when, and if. So maybe people here interpret them also differently and facilitate between these temporal relations here. But that's something that we need to study in the future, because from my experience, it is really important that we are capable of understanding the logical interpretation here, because otherwise the implementation is incorrect, and maybe there's a disagreement between the business analyst and the developer in these cases. But that's something that's interesting here. It might be also interesting, for example, to investigate other languages. So how is it, for example, in German, in Italian, in Spanish? Is it similar, or is it maybe more clearer to the reader?
Okay, thank you so much. I think that since Rodrigo is online already, we can switch the second and the third presentation. So Sebastian will get ready with a little more time. The next presentation is, hi Rodrigo, is about using a data-driven context model to support the elicitation of context-aware functionality. This is an experimental study that has been conducted. So I leave here the stage. Yeah, the slides are coming, but we don't hear your voice.
Hey, hello, now?
Remote, no.
Now? Can you hear now?
No.
Not yet?
Still nothing.
Hello, hello. No, nothing.
No. Yes.
Okay, you got something now? Yes, perfect. Thank you. Thank you for your patience. So let's get started. So thank you. Yes, my name is Rodrigo, and I'm going to present this study, which is the result of a experiment that we performed some months ago on the usage of a data-driven context model to support the elicitation of context-aware functionalities. Context-aware functionalities are functionalities that consider context to produce a certain system behavior, typically an adaptation or recommendation. And here on the screen, we have two well-known examples of context-aware functionalities. On the left side, we have YouTube. YouTube has a very well-known context-aware adaptation, which has to do with the quality of the video being streamed. So depending on the internet connection of the user, YouTube automatically sets the quality of the video so the user can watch the video without interruptions. So this is a very well-known example of a context-aware adaptation. And on the right side, we have Gmail. When you receive an email, based on the content of the email, Gmail provides you with a set of buttons that you can just tap to provide the sender with a quick response. And it's a context-aware recommendation. And from a requirements engineering point of view, doing elicitation of context-aware functionality requires an early step which has to do with context modeling. And the context modeling is all about understanding the context so we know how we can use it. And I'm going to provide you with an example using a car sharing service as a illustration. So imagine that we have this mobile app that we can use to book a car for a couple of hours, and then we can pick up the car, drive the car, and a couple of hours later we return the car. And one system-supported user task in such a system is, for example, to update the end time. So I booked the car, but for whatever reason, I want to change the time that I plan to return the car. And if I want to improve these user tasks using context awareness, I have to think about which contextual elements might relate to this application domain. So I can imagine, for example, that the user location and the user calendar and some environmental contextual elements such as traffic conditions, weather, time, and some other contextual elements related to the car. I can imagine that I have in this application domain those contextual elements, and one then has to think about how those contextual elements individually or in combination to each other influence my user task. And doing such analysis is quite complicated. It's time consuming. And practitioners, they said that they just don't do it because it's just not feasible to do such a systematic analysis to check all possible combinations. And the result is that they miss opportunities. And the idea, one idea, at least to overcome the situation, is to automate context modeling through data mining. So the idea is to use contextual data and analyze it to automatically identify the meaningful combinations of contextual elements. And we established a data-driven context modeling process that at a high level looks like this. So we have a task decomposition, and then afterwards we do the data collection, we generate a data set, and then we have the third step, which is a automated step to process the data and generate the data-driven context model, with the hope that practitioners using such a model, they are able to better identify context-aware functionalities. And for today, this is the research question. To which extent does a data-driven context model support the identification of more complex contexts and unexpected context-aware functionalities? And here, maybe it's important to provide one definition. So what do we mean by more complex contexts? We say that the more contextual elements we have in the description of a context, more complex is the context. So for example, we have here in this table 4 different contexts. In the first line, time equals morning. It's a context with just one contextual element, the time. In the second line, we have time equals morning and location equals Jean. So we have in this second context, 2 contextual elements, time and location, and so forth. So this is the idea. So as we said, we performed a controlled experiment at Fraunhofer IESE using Dorfunk as a application. So Dorfunk is a communication app with characteristics of a social network. So it has a feed. People can create posts, comment, like, talk to each other. And it's a live software development project with approximately 25,000 active users. And it has been developed and maintained by Fraunhofer IESE. So we took Dorfunk as an example, and we tried to improve the user task, create a comment using context awareness. So we run our data-driven modeling process. We analyze the data using the tools that we created. And as a result, we created this data-driven context model. This is actually just an excerpt of the model, but just to give you an idea, so it's a directed acyclical graph that somehow express some sentences that shows how the context was found to influence the user task based on the data analysis. It's not the point today to go into the details of the model, but to check how good people perform the elicitation activities with the model. In our control experiment, we had 4 hypotheses, but for the sake of the time today, we are going to focus on 2 of them. First hypothesis, age 1, the use of the data-driven context model influences the ability of individuals to elaborate requirements with more complex context. And age 4, the data-driven context model is perceived by individuals as a useful instrument to support elicitation of context-aware functionalities. We had a 1-factor with 2 treatments randomized design. So we got the people, we blocked them in 2 groups, low experienced and high experience, and then we randomly assigned them to 2 groups. The treatment group received the data-driven context model, and the control group received the list of contextual elements that they could use to come up with the requirements. So both groups generated a number of requirements, and we checked the context that were used to describe those requirements. So we had a set of independent variables, and the most important one, which was the primary factor, was the context modeling technique. And as dependable variable, we had the number of contextual elements used by participants to describe context, and the number of relevant data-driven contexts used by participants. And these were the results. For age 1, we noticed that in average, people from the control group used 1.7 contextual elements per context, whereas people from the treatment group, in average, they had 4.7 contextual elements per context. And we checked what the data was normal or not, and then we used the Wilkinson rank sum test to check the difference between the averages, and we found that there was actually a large effect size. So there was a significant difference between the results, and with sufficient power. So the conclusion is that we can accept the alternative hypothesis, meaning that these averages are significantly different, and therefore that the usage of the data-driven context model increased the ability of participants to elaborate the requirements with more complex contexts. And finally, H4 related to how useful the artifact, the context model was. We applied the UTAUT, which is a technology acceptance model to evaluate different aspects of the usage of the model. And we see here in green that there was a positive trend towards the acceptance of the model in different aspects. We'd like to highlight from the results that one interesting thing is that we actually expected that some participants from the control group would be able to identify some contexts that were present in the model, because for us at least some of those contexts that the data-driven process identified were too obvious. But it turns out that no participant from the control group, at least in the time of the experiment, was able to identify any of the contexts that were found by the data-driven modeling process. And it was interesting to observe. Of course, there was a list of threats to validity. Again, for the sake of the time, we cannot go into details. And actually, this is the message. So there is way more in the paper. I would be really excited to further discuss it with you. And if you have interest, you can ask your questions and, of course, check out the paper later. Thank you very much.
Okay, thank you very much, Rodrigo. Any question from the room? Yes, I see one there.
Hello, Giuseppe Scanello speaking. I have just a clarification question. What does you mean? What does it mean? Elaborate requirements? Because I do not understand the construct that you considered in your empirical assessment, in your controlled experiment.
Okay, thanks for the question. Maybe we'll come back to this slide. So what exactly happened here? Participants from both groups, they were asked to elaborate the requirements to improve the user task, create a comment in this mobile app with context awareness. So this was the request for that. And then they wrote the requirements in natural language. For example, when the user is in certain situation, then recommend the user this information so they could make the comment faster, for example. And they did it in natural language. And afterwards, what we did was to extract which context they used in the description of the requirements to create this context-aware functionality. And then afterwards, we analyzed these contexts. Was it clear? If not, you can please ask again, and then I can try to reformulate.
Unfortunately, I did not understand very well what is your point. My question is, what is the kind of task? You mentioned that the requirements are modeled using natural language, and it is almost natural for software engineering. Sometimes you can use also different kind of standard to model requirements. So you present requirements modeled using natural language, and you ask the treatment control to implement some modification to that requirement. So the participant in the experiment had to model other kind of requirements or something like that. This is not completely clear to me. I'm sorry.
Okay, thank you. Maybe now I understand a bit better your question. No, so I didn't provide them with any requirement that they could use to improve or something like this. So the input that participants received was not requirements. They received a task in the experiment. So the participants' task was to create requirements to improve a certain user task that I told them about. So the user task was create a comment. It's a specific task of this mobile application. And then I asked the requirements, okay, given this task, please come up with the requirements creatively to improve this user task using context awareness. So, and then the participants generate the requirements by themselves. And they have a support to come up with context-aware requirements. In the case of the control group, the list of contextual elements that are available for them to use. And in the case of the treatment group, they receive the data-driven context model.
Okay. Thank you. So we can move to the next speaker. Is Sebastian Goschalk. Primo. Okay. So the talk is about situation and domain-specific composition and enactment of business model development methods. So please.
So now? Yes, please. Okay. Hello, everyone, and welcome to my talk about situation and domain-specific development, composition and enactment of business model development methods. Today, I'm glad, my name is Sebastian Gottschalk from the Software Innovation Lab of Paderborn University, and today I'm glad to present you a piece of research where my colleague and I have worked on. But before going into the details, let me quickly motivate you the topic by looking at how business model development works. So we can see that business model development is a quite complex and collaborative process where a lot of different stakeholders have worked together. So during the business model development, you have a lot of tasks you need to do. For example, you need to interview customer or make competitor analysis. On the other side, you need to also make different decisions. For example, if you run an advertisement versus a subscription model, or if you decide to get your customers versus LinkedIn, or just by having some kind of posters in the next metro. So, but when we look at that, we see that both the task and the decisions can be supported by the knowledge of domain experts. And we see here some kind of examples of the task support and decision support from those experts. For example, we have some kind of reference models. For example, here we have for the task modeling, the Cambridge Innovation Cycle, or the book of testing business ideas with more or less a repository of experiments how to validate the business model. On the other side, you have also decision supports where you have, for example, the business model patterns where there are some kind of archetypes of good businesses, or you have even complete taxonomies of different types of business models. But as we also have seen in the keynote and also other presentations today, we see that those knowledge highly depends on the context or the domain or the situation on of the business and the company behind that. And for that, we stated a research question, how to enable the situation-specific composition and enactment of business model development method. And how we are doing that, we basically transfer the concept of situational method engineering, which is used in computer science and which I will explain later, using design science research to the domain of business model development. And by looking at situational method engineering, we see that situational method engineering promotes situation-specific construction on the fly by using existing method component. What means that? That means you have those method repository, method base or repository where a lot of method components like single fragments are in, and you have some kind of method engineer. And he has some kind of ideas how to construct good methods, and he has some kind of situational factors, which are more or less which describes the situation of the project he's developing a method for. And out of both, he basically he constructs a method, and then after that enacts, and then the project manager can enact that to run his project, mostly to develop a new software. Oh, now it skipped again. And basically this we want to transfer to business model development, and for that we're using design science research. And we use design science research as we want to have an iterative improvement of the concept, which has also some kind of abstraction that we can transfer it to different application domains by also taking the requirements of the environment into account, but also have a scientific grounding behind that. And in concrete, we're using the DSR cycle of Vaishnavi and Küchler, which has the following 5 steps of awareness of problem, suggestion, development, evaluation, and conclusion. So the first step was already done by us before, and now I want to go quickly over the second cycle inside this talk. Nevertheless, more details are inside our research paper. So, but let me start at the beginning. So we're taking an awareness of the problem, how we are doing that. So basically, we base our awareness of the problem mainly on some kind of literature. So we make a review of literature in business model development and also a systematic literature analysis in business model development tools for which directly provide some kind of decision support, how to support those business model development. And out of those, we derive the following 3 stages of knowledge provision, method composition, and method enactment. And for each of those stages, we have some kind of requirements. For example, the more knowledge provision, we need to somehow store those expert knowledge, and we need to have some kind of characterizing of the context so that we can use it later. In the method composition, we need to identify those contexts and also provide some kind of assistance, so how to really compose the method. And last, in the enactment, the whole method needs to be somehow executable, and we also need to have some kind of stakeholder involvement to solve this collaboration stuff. And based off that, we make some kind of suggestion, which we call in this cycle stage an integrated concept of situation-specific business model development. And this looks basically like this. So we have the 3 stages, as you see on the side, and we have at the beginning the meta method engineer who develops meta models. And for that, he has the method meta model, which is basically you want to model all the tasks you need to fulfill with some kind of stakeholders, situation factors, and also artifacts which are created through the process. And you have one special type of artifacts, which is like Canvas, made in the Canvas model meta model. These are basically our decisions we need to make during the process. And after that, basically different domain experts can go to your method engineer and tell them, hey, I have knowledge about this and that. Can you please add that to the both repositories? Then the method engineer is in charge to formalize all the knowledge and put it in those method repositories so that it can be used to develop different business models. After that, we have some kind of business developer who goes basically to the method engineer and says, here, I have the following situation. Can you please construct me somehow a business model development method? And this is then the method engineer takes those context informations he got and composes a development method. We have there a development method based on the BPMN modeling, which is quite highly used in practice. And we have used feature models to represent also those decisions into the structure. And last, the business developer in the 3rd stage enact those development method. And for that, he basically gets a development process out of a Kanban board where you can easily execute different development steps to develop the business model over time. And during this development, he can use some kind of artifacts, and some artifacts are especially those mentioned Canvas models, which can takes decision support out of the Canvas repository. And using design science, we have also created some kind of implementation as an IT artifact. And for that, we have made an architecture and a software tool. And today I will show you a little bit about the tool support. So the tool is called a situational business model developer. The tool is wholly accessible under open source, so you can directly download it on GitHub. There's also an online version, which you can, when you type in those URL, you can directly access the tool, try it out in the browser. It works with web storage, so you have not to install something. And here we have some kind of images what the tool can. And here I focus basically on what's in the title of the paper, the composition and the enactment. So you see for the composition of the methods, you see here some kind of BPN process where we have already focused some development steps like value proposition development or business model development, but we currently have not chosen something how to design a good feature for the business. And on the other side, we have some kind of knowledge consolidation. So the idea is that you can have different domain experts who also have different knowledges, and there's be also contradictions to each other. So we need to have some kind of merging process, which is quite similar to something you do when you make a Git request, that you somehow merge different sources and get some kind of unification source that you can use later on. Then we have the enactment. This is, again, what I showed, some kind of Kanban board where you have some kind of different tasks you can accomplish. For each task, you get some kind of information, what you should do in the task, what are involved stakeholders, what you need as import artifact and output artifacts, and you can go directly through the process. And the last image I want to show is this Kanban board, this canvas model, which is like the enactment of the models, which is here one example as a business model canvas, which is also highly used in practice. And we have also done an evaluation on the whole thing, which is like done on case study research. For that, we have conducted a single case study on OVL Live. OVL Live is a practical project by different companies in our region. So the region called Ostwestfalen-Lippe, therefore OVL Live, and it's basically an event aggregation app or platform where so you crawl different sources and make some kind of unified event experience on this application. And for that, we also need to have some kind of business model. And for that, we conducted all 3 stages. So we have this knowledge provision of method and models. This was not the focus of this paper, so it was done before. So we have the method repository of different method parts which can be used to develop a business model. This we published this year at MSAT. And we have a model repository. So there we have used the Gray Literature Review, and we have a model repository where we have gained some kind of knowledge of different decisions you have to do to build a mobile app. And this we have published at BMSD this year. Out of that, we have basically composed the development method. This is by speaking to the project manager about what's the current stage of the project and getting some information what they have already done. So mostly when you start a project, and it should be in the practice, you also start again thinking what could be different revenue streams, who are my customers and on. But we also get additional information like expected features they want to have and what's their opinion about it. And out of that, we have basically constructed some kind of development method aligned or pattern of at first you need to discover different solutions, then you need to analyze them, then you need to design some kind of business model and also features of your app. Then you need to develop the business model and also some kind of application, and then you need to validate it at the end. So, but it cannot be cycling. And during the then we have enacted that. It was mostly done by the project manager who supported us, and we derived 3 different business models. One kind of content aggregator, where you get knowledge from different sources and make revenue to some kind of advertisement links and so on. One kind of direct ticket seller, where you sell tickets and get some kind of margin out of that. And the third one was a sponsored platform, which is basically that some kind of regions pay to have their this kind of platform for their own region. So that's more or less a white label solution. So this was also everything I want to say today, and now we come to some kind of conclusion, and I hope I'm still in time. So we have the conclusion at Future Work. So today we have seen that business model development is a challenging topic that can be supported with some kind of domain experts. We have also, for that, we have introduced a situation-specific business model development approach. This has the 3 stages of this provision of the knowledge, this composition of the methods, and the enactment of the methods. And we have implemented everything in a tool called Situation Business Model Developer and evaluated it in a case study on OVL Live. In the future, we want to take another cycle, and this cycle should, on the one side, make some kind of improvements of lags we currently identified, but also we want to add some kind of modularized decision support. So the idea is that we have, for example, one development step which called like calculate business outcome, and on this step you may basically maybe want to make a rough calculation if the business model can run at the end or not. And we want to evaluate everything in some kind of lean development seminar with different students groups. So the different student groups need to develop different mobile applications and also business model for that, so that we can test the whole concept also in some kind of different contexts and find it out. So this is everything I want to say. Thank you for your attention, and now it's time when you have some questions.
Thank you. Any question from the audience or from the remote audience? Okay. Nothing? Okay. Now, just a clarification. When you report the second part, that is the canvas and the situation, can you make an example of what you are actually modeling there? Because
in the composition?
Yes.
Oh, I have a slide for that. I can, if you switch the screen, I can show a slide, which is also in the paper, but it was timely not most possible to show that here.
Yeah, just to get a better understanding. Yes.
Yeah, then I can also make it like this. So the idea is that you have in your method repository, you have some kind of small chunks, which we call patterns, which are some parts of, no, or not.
Yeah, okay.
So we have, on the one side, we have such a method base. So you see here, we have some kind of atomic fragments, which are method elements, which we combine to method building blocks, which on the short side could be said as some kind of development step you need to do your business model. And then you have method patterns, which are like small BPNN fragments, how to structure those development steps in a larger process. And then basically you use those steps. So this is the second step, where you basically characterize the context, and then you can put different of those patterns together to get some kind of larger BPNN process. And inside the patterns, you can add some kind of development steps or other patterns. And then iteratively, you can create some kind of process. And on the other side, we have some kind of feature models. So there we structure all the knowledge we gained for the different decisions we stored in those models. And this we basically used, put on some kind of canvas model during the enactment, so that you can see here basically where we have a business model canvas, the business model canvas on the outside and the value proposition canvas, where you basically can put those decisions and give the person some kind of recommendations, what could be good parts of the knowledge you could use or not.
Okay, thank you. Any other question in the meantime? No? Okay, then thank you again. And we can move to our next speaker, who is Stefan Treflinger. Okay. Yeah, you should be. Okay. This talk is about the transformation model for product or mapping in dynamic and uncertain market environment. So, please.
Thank you very much for the introduction. Hello, everyone. My name is Stefan from the Reutlingen University, and I've been a PhD student since the 1st January 2019. My co-authors from this paper are Jürgen Münch, also from the Reutlingen University, and Stefan Wagner from the University of Stuttgart. In the next 10 minutes, I will discuss the development and validation of our product roadmap transformation model that aims to guide companies to transform their product roadmap practices to the requirements of a dynamic and uncertain market environment. Sorry. So first of all, I will start with a quote from Martin Cajan. Mr. Cajan is a partner at the Silicon Valley Product Group, and he said, "I see typical product roadmaps as the source of so much waste in product teams." So what does Mr. Cajan mean by that statement? Cajan means that nowadays we can observe that the environment for creating new products, services, and business models are getting increasingly complex. The problem is that with a high uncertainty in a dynamic market environment, it is almost impossible to predict which products, features, or services will satisfy the needs of the customers, especially in a long time horizon. One consequence of the situation is that products, services, or features are developed that are not or only seldom used. And this results in the situation that organizations are facing the challenge to provide a flexible product planning in order to develop successful products in a dynamic and uncertain market environment. In this context, in order to plan the future product portfolio, usually product roadmaps are used in practice. Product roadmaps are strategic communication tools that map out the vision and direction of a company and the work that is required to get there. And in this context, a study we conduct on the state of practice of product road mapping show that the most common approach is a traditional format called feature-driven roadmaps. The aim of feature-driven roadmaps is to inform stakeholders at which point in time a product is ready to market launch. However, the structure of such feature-based roadmaps makes it difficult to make adjustments that are necessary in a dynamic and uncertain market environment. Moreover, this approach considers only outputs, such products or features, but not customer goals or business needs. And for this reason, feature-based roadmaps works well in market environments that are predictable, stable, and reliable. However, through increasing market dynamics, rapidly evolving technologies, and shifting user expectation, this approach often does not work anymore. This leads me to the question of how can companies escape feature-driven roadmaps and transform them into suitable approaches for dynamic and uncertain market environments. In order to provide answers to this question, we developed a product roadmap transformation model, and therefore we organized expert workshops with 2 researchers and 3 practitioners. This workshop led to the development of the transformation process itself, recommendation to conduct each step of this process, as well as 2 mapping tables in order to identify suitable measures to improve the product road mapping practices. So far, the background and the methodology. In the following, I will present the details of our product roadmap transformation model. That starts with an assessment of the product road mapping practices currently in use. In order to provide such a tool for such an assessment, we developed a product roadmap self-assessment tool called DEEP. Overall, the DEEP model consists of 9 relevant dimensions. With each dimension represents a relevant aspect for the success of product road mapping in a dynamic and uncertain market environment. Examples for dimensions are which items are used on the product roadmap, how often and in what manner the roadmap is adjusted, or which stakeholders are aligned with the product roadmap. Furthermore, each dimension is assigned to 5 stages that represent some kind of increase of maturation. In order to reflect this maturation, we defined a score for each stage. As you can see in this picture, there is some kind of increase of maturity from the left to the right. The idea of such a scoring is that practices are comparable with respect to their maturity. As a result, a company can perform a self-assessment by answering all questions and selecting the applicable stages for each dimension and summing up the corresponding score. This slide shows the level of the DEEP model after summing up the points of the selected 9 dimensions. The minimum score that can be reached is 9 points, the maximum is 100. In simple words, the higher the level, the more orientation and confidence the roadmap provides and takes into account the delivery of value to the customer and the business. However, a user does not receive any recommendation as to which measure should be implemented in order to reach a higher level. And this leads me to the question of how can companies improve their maturity level with respect to the DEEP product roadmap assessment model. The answer of this question provides a process to guide companies to transform their current product roadmapping practices to the requirements of a dynamic and uncertain market environment. Based on the results of the DEEP model, the first step of the transformation process is to analyze which dimension of the DEEP model promises the most benefit of improvement. In more detail, in case that the assessment with the DEEP model results in the overall maturity levels of 1 or 2, we recommend to select one of the dimensions in the box on the left. The reason why the dimension prioritization got excluded is that an essential success factor for an effective and efficient prioritization process for a dynamic and uncertain market environment is to understand the value that should be delivered to the customer and the business. If a user of the DEEP model selects a stage that not considers the factor customer value independent of the dimension, this leads to an overall maturity of level 3 or higher. Consequently, a company at level 1 or 2 does not include a customer value, which is an essential aspect for the prioritization in the road mapping processes, and thus an improvement of the dimension prioritization within these levels is not advisable. The reason for excluding the dimension extent of alignment is that the product roadmap should be in a sufficient mature state so that stakeholders are able to align their activities with their roadmap. Therefore, the dimension alignment should not be considered until the product roadmap has reached a higher level of maturity. The next phase of the transformation process is called set goals and choose measures. The detailed process of this step is shown at this slide. In more detail, one clear improvement objective should be defined, as well as corresponding measures that contribute to the achievement of the defined objectives. An example of an objective would be the improvement of the dimension roadmap items from level 2 to level 5. How the question arises as to how suitable measures can be identified. And therefore, we developed two mapping tables which are built on each other. This slide shows the first mapping table, which is called Goal Opportunity Map. A user can apply this mapping table by entering the previously identified dimension by the deep model in order to obtain an artifact that is needed to improve the corresponding dimension. This is marked by the crosses that connects the dimensions and the artifacts. For example, the dimension roadmap items can be improved by developing the artifact product vision, while for the improvement of the dimension product discovery, the development of ideas and assumption can lead to an improvement. However, the application of the goal opportunity map does not provide answers to the question of what activity must be performed in order to develop the required artifact. In order to answer this question, we developed a second map called goal activity map. In order to obtain such a measure, the user must enter the artifact obtained by applying the map before. For example, the creation of a product vision can be created by conducting a product vision workshop, while ideas or assumptions can be formulated by the conduction of customer interviews. The next phase in the process is the phase execute, that has the objective of conducting the identified measures in the previous phase, as well as to analyze their impact on the road mapping process. And finally, the phase operate consists of additional tests in order to ensure that the conducted measures operate in accordance with the needs and requirements of the company. So let's talk about the current state of the validation of this product roadmap transformation process. As first step of the validation process, we provide a transformation model to practitioners without any explanations and instructions, and asking them to apply it in their respective company context. In order to gain insights, we conduct an interview with each participant after this application. And overall, the participant perceived our model as applicable and useful. Moreover, we conduct a multiple case study with two various companies. In this context, we apply the deep model as a first step in order to gain insights into the current state of product road mapping in each company, as well as to identify the most promising dimension of improvement. On this base, a goal was formulated in cooperation with the product management of each company. The goal of one company was to improve the dimension roadmap items by including outcomes into the roadmap. The goal of the other company was to improve the dimension extent of alignment by creating a product vision. In both cases, the creation of a product vision was the first step in order to achieve these goals. This slide shows our findings regarding the impact of a product vision on the dimension roadmap items. Regarding the impact of this, we can say, so we notice that the product vision helps the product team by the formulation of the outcomes. In more detail, the product vision serves as guidelines for the definition of those outcomes that must be satisfied in order to fulfill the product vision. Therefore, we can say the creation of a product vision supports the improvement of the dimension roadmap items. Regarding the impact of product vision workshops on the dimension extent of alignment, the study shows that our product vision serves as a basis for the creation of a central product roadmap that reflects the needs of all stakeholders. In this context, the product vision helps to include only content into the central roadmap that is aligned with the needs and requirements of all key stakeholders. Therefore, we can say that the creation of a product vision by a workshop supports the improvement of the dimension extent of alignment. And finally, I would like to summarize the results of our study. First, feature-based roadmaps are too static and makes it difficult to conduct frequent adjustments, which are necessary in a dynamic and uncertain market environment. And finally, practitioners can use our product roadmap transformation model in order to determine their current state of product road mapping, determine improvement potentials, and as well as to identify and conduct suitable measures in order to improve their product road mapping practices. With these words, I will close my presentation. Thank you for your attention, and now I'm looking forward to your questions.
Okay, thank you very much. Any question from the audience? Or from the remote audience? Remote, no? No? Okay, then I have a few questions. So you mentioned that you have this self-assessment tool for the companies. I'm just curious about if you applied it sometimes, what is typically the average maturity level of the companies that you find in your applications?
Yeah, start with the self-assessment, of course. Let me start at the beginning. As first step, we conduct expert interviews, and we find out that German companies typically use these feature-based roadmaps, typically traditional format of product roadmapping. So, but their problem was, they know we have bad product roadmapping practices, but they have no idea how to start a transformation or the adaptation of, to a dynamic and uncertain market environment. And therefore, the first step was to conduct the assessment with the deep model in order to gain insights on the state of product roadmapping, identify improvement potential, and as an eye-opener to the management. This was a very important point. And then you can systematically set an objective with help of the mapping tables to table measures in order to reach this objective. And you conduct the measures, and a very important point is the review and retrospective in order to identify does the measures lead to the achievement of this goal? Very important point. And then you can go to the next iteration. We start with a self-assessment. Then the world is dynamic. For example, internally, you have a new head of department of product management. They have introduced a new process. And this has impact of your product roadmapping process. Therefore, for this reason, start with an assessment and then go through the process. Yes.
Okay. Concerning the two main tools that are at the table that you propose as an instrument to identify the given the goal, the opportunity, and how you can achieve that. Do you think that they are at the current stage stable, or do you plan, for instance, to refine them, to provide more detailed guidelines? For instance, you mentioned a workshop. Maybe you can provide more details about how to conduct a workshop to better achieve the improvement.
Very good point. Thank you for the question. Yes, and we plan to extend the mapping tables. This is the current state of the mapping tables with quite simple examples. For example, customer interviews, and so on.
Yes.
We have conduct for creative literature analysis, and at the moment we expect the insights. Furthermore, we conduct customer interviews, and we work together with a lot of companies. For example, Bosch or Daimler from Germany, and also small-sized companies and mid-sized companies. And their plan is to extend the mapping tables, and also to give insights how to conduct this, what have you to do to successfully conduct the customer interviews.
Yes.
That is the plan for the future.
Okay. Thank you very much.
Thank you.
Thank you again. And we can now move to our next speaker, Vlad Stilbu, last from this session, that will talk to us about traceability in GitHub, but specifically for medical software. Just a few seconds to get the slides. Okay, please.
Hello, my name is Vlad Stilbu, and today I'm going to talk about our work conducted at Compliance Palette and University of Helsinki. We have my co-author, Tomi Mikkonen, is a full professor at University of Helsinki and University of Jyväskylä, and if I will reveal a little secret, they will be the host of next year conference. So we are going to talk about traceability in the context of medical software development, and more importantly, how to achieve this traceability using a common tool as GitHub. So why it is important, or why medical software is we selected. So medical software has some unique characteristics due to its sensitive nature. So if you develop medical software, you need to ensure its safety and effectiveness so that the software does not cause unintended harm to the patient. And then you have, as a manufacturer, you have a solid way to consistently manufacture and build the product. And as we can see here, you need to comply with a large number of regulations. So we have here, you need to, as a manufacturer, you need to implement procedures that will have, so for quality management, patient risk management, and then there are specific expectations how the products are built. And because nowadays a lot of, let's say, innovation in medical software is delivered via software, there are quite strict regulations on how the software, so the software development life cycle, and then of course they have user interface and there are usability concerns. So as we can see, there are quite many things that you need to consider, and this is just a subset because the new regulations like MDR comes with additional layers like privacy and cybersecurity. So in order to be sure that you are able to provide this safety and effectiveness, so the regulators, they have this concept in mind that, okay, you need to ensure that you have and you are able to impose design control. So if we look here, so this is originated from the regulators in Canada sometimes in the 90s, and it was adopted by everybody now. So you start with the user needs and they are reviewed. You have design input that is converted during the design process in a design output, and you need to verify that, okay, these ones, so the output meets the input, and then the end result, which is the medical product, is validated against the user needs. So it sounds quite simple, but if you map it to what you have to do with all these standards, things are a bit hairy. So it is the same. So you start with the user needs and then you refine them into the user requirements, system requirements, are high-level software designs, low-level software designs, implementing, and then do verification at all this level, and then validation at the top level. So quite a lot of things to do. And what you need to do is when we are talking about traceability, that the stakeholder rationales can be tracked to the product requirements and then to the designs and all the artifacts that you have created during your process. And what is the challenge here? So traditionally, these activities have been performed using application lifecycle management tools, and quality and regulatory people, they are let's say, skilled in handling them there. But as we say that, okay, a lot of stuff nowadays is happening in software, the software developers have moved, or they spend their majority of time in tools like Git to track what they do, IDEs that help them to develop the software. And we start to notice that there is an increasing gap between these two categories of people that are involved in the product development. And to make things a bit worse, I would say that on the regulatory side, things are done traditionally in a plan-driven fashion, but here on the software side, they are in an iterative and evolutionary fashion. So what might have been here, at some point you have a common, an overlap. So developers that know about regulations and quality people that were aware about so all the new technologies, so polyglot, so use more languages to develop a product, use more databases, cloud systems. So it's very, very difficult to have a single picture of this. And this is a challenge. So the objective of the study that we have done is like if we can take the activities that are done here and move them on this side so that we have the team work at using a common set of tools and using, let's say, a single cycle. So keep them, because otherwise keeping these two islands synchronized requires a lot of effort. And GitHub, and we selected GitHub because it's like the most popular out of the Git alternatives that are on the market. It happens to have quite good features, but they are not used maybe to their full extent because it requires some sort of expertise. So if we look here, so on the first row, so in the column, we have the traceability and what would be the GitHub capabilities on which you can implement. And then the third one is like the implementation in practice. So the user needs, the system requirements, software requirements, they all can be mapped into the features. So the issue tracker in GitHub will serve it well. And because you need to help the people to, because in GitHub they are just markdown files, so it can be anything there. So in order to guide them to contribute the necessary content, you need, so GitHub has templates. And here we have templates for all of this. For like whenever a change is introduced in the system, so this would be like the vehicle to introduce change. In GitHub, we have the pull request, and pull request is like a set of changes, and they can be, they can take any form, so they are just files there. But because you know to which issues are related, they start to make sense, and you have a context, and it is easy to understand what is happening there. The trace, so how these connect together. So GitHub has references, and this allow you to build a graph. So the issues and the pull requests are, they form a graph, and this is exactly what you want with from the traceability perspective. And this is something that is like a plus there. So it would be nice if you are able to convert the issues into executable issues and test them and see how they are, like they can be run on any change, on any pull, it is like any commit, and also in the pull request. And for that, our experiment worked with Gherkin. So this is like a language originated from Cucumber.js, but is supported by many languages nowadays. So using this, we were able to build a traceability information model, and we have the user needs, we have system requirements, software requirements, the change request, and the test cases. And this forms an effective way of implementing traceability. So this is like screenshots from GitHub on how to do it. And actually what we do with CompliancePal is that we enhance, so the service enhances the body of the issue with a traceability report, so that you have the references and the decomposition of the issues there. So they can be followed by following the UI, the GitHub UI with the hyperlinks. Yeah. So far, I talked about like this is like a good enabler. So it allows you to do the traceability. But let's say that GitHub might, or the Git itself might not be for everyone in the organization. And what we would look at next is like to build some custom visualization so that you have, like, instead of traversing the links there, have like a single view, like of the entire graph that allow to go deeper. And then look at other Git vendors and how this will work with GitLab, for example, which is another option. And if you have any questions, me and Tommy, we are happy to answer right now or later.
Thank you. So, any question from the stage? Yes, I see one there.
Okay, yes. So thanks for the presentation. So traceability is a long-time problem, I think, that we as a software engineering sub-community, we never solved, honestly.
Yes.
How much it costs for those developers in that domain? Because I understood that most of the things are manual, right?
Well, not entire. No, I don't think that. So there are manual, but so the ALM tools, they solve it.
Okay. Okay. But did you try to put it in practice and get some inputs, or will be maybe future work?
Yes.
I mean, I'm very curious because I've been doing time to time a few works, but I'm following a little bit this, traceability community. I still see that we try many things like recover information or putting explicit information, but I feel that overall as a community, we are still kind of far away from what we would like to get.
Yes. So we are having activities with a couple of manufacturers. So we are based in Finland, so they are there, and they have. So they were using before GitHub for this, and they have been like a very good fit to experiment with this on their system, because it would be like in a way a formalization of what they do. And the results so far are that, so they have already a system, so it's not that easy to move into this, because it's, but the feedback so far is that this way of doing fits quite well. What would be like where we need to develop it further is like provide a bit more concrete guidance of what goes into an. So when you implement a piece of functionality, what constitutes design input and what constitutes design output, and especially as you develop using agile methodologies where there is no clear cut of like this is the input and then this is the output. Yeah. So because they get refined, and this is something that this guy, like how to classify the content and put it in the right place. Like, does it belong to the issue or does it belong to the pull request? And then what we have done with this executable test is that as you start, so you have the issue, and as you start to develop, if you are following test-driven design, you start to formalize these gherkin tests, and then the tool includes this gherkin test into the body of the issue, so that if you just want to browse and see what is going on, you can see it there. So I think that the user experience is something that probably the users are not yet accustomed, because they expect something like, probably they have used Jira, to not name others, like and this thing that you can do all the traceability using the tool that you already do it during the day-to-day. But then the other aspect is that while developers are, let's say, very familiar with the tool, if you are like a quality, like a regulatory professional, you might not find it that easy. And then, or you might need to find information in too many places. And that's why we provide custom UIs that allow you like this kind of graphs and easier way to navigate. But that's like the way to do it.
Yeah, I'm sure that you're already doing, but be sure to collect the cost and benefits of their previous approach. and then to compare with cost and benefits of your approach with traceability, with explicit traceability. Because my understanding that a big barrier is when you go with these techniques is the cost that they have to pay at the beginning. So if they don't understand what are the real benefits, and I know there are many, especially when the system evolves in many years and there are many documents, many factories and so on, but be sure to trace the cost or the issues that they had with their previous non-tracing system to strongly justify why this kind of approach is really required.
Yeah, well, yes, I understand like this like how to. Although I'm more like from industry, so I have also a like academic hat and there, but coming from also with my industry hat, I think that so. Another thing to consider is that there are way too many ways to implement the same thing, and it is not as easy to compare the costs just because these tools are like, so even if you use the same tool, like Jira, the things that you build on top, because Jira is the same, it's a very raw like tool, yeah, like it's a toolkit. It starts to be comparable and over time. So this is one thing, like if you are, so if I'm allowed to say, like the old world and the new world, yeah, like keeping, so in the old world, it was simple because you have one tool, kind of like plan, or the plans are more like crystallized, yeah. But here there are hidden things like that cannot be captured in the old model. Like how do you keep it in sync, and how do you ensure that the actual implementation, because that's the product, the actual implementation does not drift from requirements and things like this, and how what is the delta, like the cognitive delta between the text of the requirement, and there have been a talk before about this if. So what that if means there and how it ends in the code. And then if you start to have multiple tools that you put together, things are getting tougher and tougher and tougher.
Thank you again. We can move to lunch. The lunch is in the same place as the coffee break. We have more time for the lunch.
Sure.
Okay, welcome back to the PROFES conference after the lunch break. My name is Riccardo Coppola. I will be the chair for this session about human factors. The first paper that will be presented is a paper by Rita Francese, Giuseppe Scagnello, Gianni Tortora, and Vincent Milione, and will be about an empirical study on personality traits and team climate in a smart working development context. So the presenter will be Giuseppe Scagnello. So please, Giuseppe, I leave the stage to you.
Thank you very much for your nice presentation. This paper comes from a collaboration between my university, University of Basilicata, and the University of Salerno, as the one I have presented this morning. Okay, smart working. Let me say something about smart working. Smart working is a model of work that uses new technologies and the development of existing technology to improve both the performance and the satisfaction that is obtained from the job. This is a definition I have found on the web. You can find a lot of other definitions, but more or less the meaning is the same. Before COVID-19, many of us applied this kind of work, this methodology of work, to achieve better results and, of course, better life balance. Many of us work at home, someone in a pub, in a bar, and other guys like this woman also on the street. So everybody of us work in every place, in the place that she believed the best for the work for his life. During the COVID-19 pandemic, smart working was a necessity for a huge number of workers. And indeed, the only chance, the only possibility was to apply smart working at home. For some of us, working at home was a pleasure. For something from some other people, indeed, was not so nice to work at home because of a number of interrupts also from child and wife and something else. Indeed, smart working in the definition I've provided to you and in our collective imagination needs of a kind of interaction with the other colleagues and with students for people coming from the academia. And of course, the software development is not an exception. Developer needs to interact with other developers, with testers, software architect, with project manager, with customer, and so on. So a huge number of stakeholders have to interact to get a common goal develop a software application or an app for smart devices, for example. So developers in distributed software project have to interact, but they have different personality that can play a role in the development and in the success of a software project. But their personality can also affect time climate. Time climate is one of the aspects that can determine the success or not of some part of a software project. So, at this point of my presentation, I think that it could be not clear what does personality trait is and what does team climate is. Let me give another couple of definitions. The first one concerns personality trait and is a definition by Psychological Association, American Psychological Association. And this association defines personality trait as a relatively stable, consistent, and enduring internal characteristic that is inferred from a pattern of behavior, attitudes, feeling, and habits in individuals. So it's very rigorous definition that in many cases is very difficult to understand for those people that don't have some familiarity with psychology. Team climate is closer to our perspective, to our, it's closer to software developer and computer scientists in general, because team climate is defined as a shared perception among the team members of teams, work procedure, practice, and member behavior. So it's more close to how we feel on what we feel about the work with other people in the same team to get a common goal. In the literature, we have a few studies that try to correlate personality trait and team climate. Many of these papers have been published before pandemic, and many of them, almost the totality of these papers focus on software development in practice, but in person. So they are not focused on smart working, and they are, of course, not focused on pandemic. And then, for this reason, our research can be considered a kind of next step in that direction. So we try to investigate if there is a correlation between time climate and personality trait, but we focused on team that develop smart application, and these team were asked to develop app for in the context of multi-platform, so hybrid solution for smart devices. Just to recall to some of you, but I have just touched this aspect in my previous presentation. In the context of hybrid development, we have to implement an application once, and then we can deploy that in different native platform. We have a number of technologies, frameworks that allow to develop a hybrid or multi-platform application. Ionic, PhoneGap, Titanium, and React Native, that is the framework that we have used in this experimental assessment. And each of these applications allow to deploy the app in different operating system, different native framework like Android and Mac and iOS. There is a growing interest from the industry, from the academia, about the development of app for smart devices, but also for the development of application for these smart devices using hybrid technologies. As we can see from some of the results we can find on the web about the growing interest and the growing interest from the industry and the amount of money that the industry is spending on these topics. So the goal of our experimental assessment was using the GQM template, analyze personality traits and team climate for the purpose of understanding their correlation with respect to development of multi-platform application for smart devices in the context of distributed smart working development teams composed of computer science students during the pandemic COVID-19. To assess the personality trait of software development of the participant in our study, we used the Big Five personality models, also known as Big Five-factor models, to get information about this model. We use IPAP Neo 120. This is a questionnaire, is an inventory of 120 questions that we have administered to the participant to classify the personality of the students on the basis of these 5 dimensions, such as openness, conscientiousness, and agreeableness. About the time climate, we use another model that is Team Climate Inventory, TCI. It is based on 4 dimensions: vision, participation safety, support for innovation, and task orientation. I'm sorry, but for the short time, I can go inside this dimension. If you want, you can find the further detail in the paper. The participants were students of the Master Degree in Computer Science. The average age was 23, more or less. And also, in the case of the lunch, we have a small participation of women in the experiment. In the lunch, we have just one woman that is there. But the same happens also for experiment conducted with the students. Only 3 female, 6% of the total of the participants in the experiment. Students were grouped in 19 teams and were asked to develop multi-platform app with the front end and with the back end. So this is the plan of our study. The course started. We get a consensus form. We asked to fill in the IPIP Neo 120. Then we asked to implement the hub the students have decided to implement in their project of the course. They were asked to use tools like GitHub for the management of the project and to conduct a synchronous meeting using Microsoft Teams, but indeed we did not force students to use any kind of specific technology. At the end of the project, we asked to fill the TCI inventory, so to get the time climate of the participant in the groups. Here we can see some box plots to show the distribution of the data we gathered. In particular, we can see data for the time climate on the right side, while the information about the personality of the participant on the left side. As we can expect, informatic students are not so open to work with other guys, while the median of the other box are after the 50%. We observed from our data analysis that there is a correlation between extroversion and vision, between extroversion task orientation, and support for innovation and participation safety. This these are the main results we have obtained from our data analysis. So it seems that the only dimension about the okay, I have to the only dimension that is correlated with the team climate is the extroversion of the participant in the team. So it is significantly correlated with the dimension of the team climate. Of course, as any empirical assessment, we have some threats to validity. We devise as the kind of project a threats to internal validity. The user tools to develop and to communicate represent another kind of internal validity traits. While since we used one variable for each construct, we can have also issue related to construct validity. Of course, about the external validity, we have the small number of teams involved in the study, and also the fact that we use students with respect to professional. This represents another kind of external validity. This is the outline of my presentation. I conclude. If you have any question, I'm here to try to answer that question. Thank you.
Does it work? Yes. Thanks for your nice presentation. Just one detail. How many people per team?
About three students for each team.
Okay.
So it can be considered as a small
team
in agile development approach.
And anyway,
so we did not impose any kind of process to develop. Of course, they have some experience in the context of software engineering, and they have experience in the design of
and the teams were. Did you define the teams or the students?
The students decided to compose the team on the
before
basis
the personality trait question.
The personality trait was filled in after the team composition, and it does not depend, or at least the personality trait should not be affected in a short time. So you can change your personality in the long run.
No, the question was actually the teams were formed sort of random, or the students decided, so you didn't use any criteria based on personality trait or whatever else.
Yes.
Okay, thanks.
Thank you for the question.
Thanks a lot. I think that was very interesting, at least for me, that is new. And I have a question more to you from your experience conducting this study. Do you observe any evolution of personality characteristic across computer science or software engineering students across time? Because we have these stereotypes in mind from the past that computer scientists are introverts, and now you talked about extroversion, that is very important. So I was wondering if you observe any evolution in the,
Indeed, we were not able to understand or to observe evolution in the traits because we filled only once the IBIT Neo inventory. But there are a number of studies in the psychology field that observe that experimental state that you can observe some difference in the at least 6 months, but the difference that you can observe are not so significant in the long run, also in the long run.
Okay, so I think that we do not have any more questions. We don't have online questions. So I would like to thank Giuseppe for his presentation. And we can move to the next presentation, which will be an online presentation. Will be about a paper by Sosuke Masaki, Hiroi Salman, and Tomoyuki Yokogawa about searching for bellwether developers for cross-personalized defect prediction. So if everything is fine,
can you
I
hear
will
me?
leave the stage to Sosuke.
Okay. Oh, just wait. Okay, I share my screen. Can you see my slide? Okay. Okay. Can I start my presentation? Can you see my slide? What? Can you hear me? Oh, can you hear me? Okay. 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 Let's start my presentation. Today I'm talking about our paper titled Searching for Bellwether Developers for Cross-Personalized Defect Prediction. Okay. Okay, I'll start to introduce software defect prediction, or SDP. It's an active research topic for decades. Traditional software defect prediction utilizes static code metrics such as cyclomatic number to characterize software modules. Therefore, the unit of prediction is file, class, or methods. Nowadays, software projects are formed around a repository that recording software development activities. Just-in-time software defect prediction, or called JIT SDP, utilizes those records to characterize code changes like this. JIT SDP is a defect prediction model utilizing all code changes of a project. The diversity of developers may make the code changes heterogeneous differently. More homogeneous sets of code changes may contribute to better defect prediction. Version control systems enabled us to attribute code changes to individual developers like this. So, personalized defect prediction can be implemented now. Personal defect prediction utilizes one's own changes for learning a prediction model. These changes are homogeneous and expected to improve the prediction performance in comparison to defect prediction using all commit data. But one drawback of the personalization is the reduction of dataset. Furthermore, some developers are not active and made a few commits like this. So small datasets have small information and may be insufficient to learn an effective model. Uh, the same situation is considered in traditional defect prediction, and it is studied to use datasets of other or called cross project. So it is called cross project defect prediction. And we consider the same idea was uh, examined on the SDP. And so cross-personalized defect prediction can be uh, realizable. Uh, so uh, cross-personalized personalized defect prediction means it applies the same idea to personalized defect prediction. It uses other developers' commits to build prediction models. For example, one of them is selected for prediction. Here, the red person, but sometimes other person can be utilized for defect prediction by, for example, combining the prediction results. Okay. Okay. Here, I explain the core of our research idea, the weather approach application for our situation. Many cross-project defect prediction approaches have been proposed, and the bellwether approach is one of the approaches. For personal defect prediction, each data set comes from each developer. The bellwether approach first enumerates all pair of datasets, and for each pair, the one is used for the model construction, while the others is used for its evaluation, like shown like here. Finally, the best developer in the prediction performance is specified as a bellwether, selecting the one person. The bellwether approach was proposed and examined for traditional defect prediction. So here our question is, how does the bellwether approach work when cross-personalized defect prediction, as depicted here? We just set these three research questions. The first one is how often bellwether exists among active developers. Second, how are the bellwethers effective for predicting faults made by the other active developers in a project? And the final question is, how are the bellwethers effective for predicting faults made by the rest of the non-active developers in the project? Okay, let's move on answering these questions. Before that, I explained this set usage in each research question. Here shows an example of this set comprises two active developers and other non-active developers. Each developer made commits, and here the left side of commit sets are considered older commits, and the right commit subsets are considered newer ones. To answer research question 1, we use these older commit sets to find bellwether. Then we specify bellwether developer. To answer research question, we use these dataset to model learn models to predict newer commits and compare the performance among active developers, especially in comparison to bellwether developers. Then we use these non-active developers data as a test set to compare the performance of prediction models made by active developers, including bellwether developers. Okay, let's move on the answer to research question 1. Here, the graph shows performance distributions among developers to find bellwethers. X-axis represents each developer, and Y-axis represents the prediction performance. Here, the higher is better. As you can see, two not ordinal developers showing the clearly better performance. These ones, each one is bellwether, so we named they a flock of bellwethers. We use 9 OS project data to examine the existence of bellwethers and find 4 projects had a single bellwether developers, and the rest formed a flock of bellwethers. That is, we could find we were able to find bellwethers in all OSS projects. Okay, to answer research question, we compared performance of bellwethers and other active developers. Here, the table shows 3 cases: effective, marginal, and ineffective. Here, effective means bellwether model was significantly better than the other active developers. As you can see, most of the cases fall in the middle, marginal cases. So we can see the bellwethers found in research question 1 were not significantly effective. So our answer is use one's own model. Finally, we compare the active developer models on non-active developer commits. That means bellwether found in the bellwether approach keeps the top place when comparing, when using the performance on non-active developer commits. And the answer to this question, we compare the performance results and find the bellwethers were not necessarily the best choice, but the practical choices. Okay, here is a conclusion. We examine the existence and the usefulness of bellwethers on cross-personalized defect prediction, and found bellwether developers were in all projects. The bellwethers were not effective for other active developers commits, but they were practice choices for non-active developers. As future work, we plan to examine what makes them as bellwethers, his experience, his expertise, and so on. And we plan to examine their cross-project bellwether developers. That means a bellwether in one project can be a bellwether in another project. That's all. Thank you for your attention. Okay. Oops.
So, are there questions on the YouTube channel? Okay, so we have no questions from the YouTube channel, but we have one from the audience.
Mm-hmm.
Giuseppe Scagnello is speaking here.
Yeah. Hi.
My question is about external validity. Do you think to what extent your results can be generalized in real software projects?
That's a very, very difficult question. All empirical analysis results are limited to the data examined. We can augment, use more data to examine the results, but I can't say it is impossible to say our results can be applied to all other projects, but we use can you see the proceedings? We use very different projects in terms of the number of active developers, commit sizes, and project period. So, and we found bellwethers in all projects. So, it can be strong, I'd like to say strong evidence our finding can be applied to other projects, so can be generalized to other projects. That's my belief. So I cannot say theoretically our result is very generalizable, but it's my answer to you. What do you think about that? Okay, thank you.
Okay, is there any other very quick question from the audience? Or, okay, I don't think so. So thank you, Sosuke, for your presentation. We are a bit late on schedule, so we have to move to the next presentation. So thank you again for your contribution, and we can move to the next one. So the next paper that will be presented is a paper by Chi-Hong Lee and Tracy Hall about using machine learning to recognize novice and expert developers. So I see that the presentation is already there, so I leave the stage to Chi-Hong.
I assume that everyone can hear me, so I'm going to start the presentation. So yeah, so this is a paper by me and Tracy Hall, my professor. So background on co-stylometry. So co-stylometry is the analysis of source code or compiled binary files. It's an analysis of those files, and the main application currently is for authorship attribution, which is to determine who is the author who wrote a piece of code. And there are many things that we can extract from the source code or compiled binary to try to determine who is the author, right? So for example, we can use Halstead metrics or n-grams of source code. So all these metrics can help us establish sort of the profile of the author. So combining co-stylometry with machine learning, there's been many studies, using this technique. They tried to use different models, different data sets, different source of data, and the results are varying. Some are very good, some are not quite as nice as other ones, but most of these studies are only for authorship attribution, which is to tell who is behind a piece of code. For our project, we are not trying to analyze code and say who wrote it, but more to say whether if the person who wrote it is an expert or novice. So we're trying to characterize the author. There are few few researchers on this topic, and we thought that this could be applied in two main scenarios. The first one is for higher education institutions. So there's been studies showing that if you can group programming students into stronger and weaker students and apply different teaching techniques, it could really help them learn more efficiently. And for companies, it's been shown that just using GPA to filter through job applicants isn't reliable, and companies would often lose some great candidates purely because their GPA might not be as well as others. So with this model, if the company could tell if one is an expert or novice, it could help them in the hiring process. So the source of our data. So we are collecting only scripts from developers. We are not going to analyze a whole project, a whole repository. So we're only collecting solutions to a coding problem from different authors. And we are trying to get code from either expert or novice. So we've decided to get the code samples from HackerRank. HackerRank is a competitive programming site, so people go on there and solve programming problems. So they get an input like the one shown on the screen currently, and they produce some code to solve the problem. And we chose HackerRank because they provide a leaderboard, which we can use to see others' profile and their submitted solution to the coding problem. And on the profile page, sometimes they have a link to their LinkedIn profile, which we use it to establish whether if they are a novice or expert. So with that, we have a piece of code and the LinkedIn profile of the author. So onto data labeling, how do we separate novice from expert? So a definition of novice is one that does not have any programming related work experience, and expert as someone who has any full-time work experience. So we do recognize that a programmer's expertise is not binary in real life, so they are not just either novice or expert. But for the simplicity of this project, we decided to move on with this novice and expert. So onto the experiments. So we are using Python and scikit to perform the training. We evaluate the accuracy of our model with 10-split k-fold cross-validation. For all experiments, we use the same 10 models to perform the tests. As listed on the screen, we intentionally chose a wide range of models to see how do they perform. So the 6 main experiments. So the 0 one is the baseline one. So we collected 199 code samples. 108 of them were from experts, and 98 of them were from novice. We used 15 features. Those are very basic features, such as the number of lines in the file or the ratio of empty lines to code in the file. So these are very simple features. And this baseline experiment resulted in a 0.643 accuracy in the top 5 models. So that's the baseline. The first experiment was to clean the code. So in HackerRank, when someone submits a code, there's a section of the code that is identical in all submissions. So we remove that part, we remove the common part, and it resulted in a slight increase in the accuracy to 0.662. The next experiment that we did was to try out half-step metrics, because we saw that in a lot of other code stylometry researchers, they used this metric to do different stuff, to analyze the code. We tried just using the half-step metrics for the features or combining the half-step metrics with the original 15 features. Both didn't do particularly well, so we moved on to the next experiment, which is to add a cyclomatic complexity feature. Basically, we added this feature with the 15 baseline features, and it improved the accuracy to 0.67 when compared to the baseline. The next one, we tried something a little bit different. We tried to analyze the style of the code. So we added 2 new features. The first one is whether if they had a space in front of the brackets. And the second one is whether they use a new line before of a curly bracket. That also improved the accuracy to 0.669. And the final small experiment that we did was normalization. So we tried min-max scalar and standard scalar. The standard scalar one performed well, resulting in a 0.663 accuracy in the top 5 model. So the green experiments that you see on this slide are the experiments that contributed to the final experiment. So our final model was, we used the same samples as the baseline one, so the 199 samples, with the common part of those code removed. And we used the base 15 features, plus cyclomatic complexity, plus the 2 code style features. And we also applied standard scalar to the final dataset. And this resulted in the top 5 models an accuracy of 0.678. And the best model was logistic regression, which the accuracy was 0.713. So on this graph, you can see the red bars are the accuracy of the models. And for the best model, the logistic regression one, the coefficients are as follows. So there are some interesting stuff. So on the y-axis, 1 is for expert, -1 is for novice. So from this graph, we can see that the more novice are more likely to add comments to their code when compared to expert. So at least from the model's perspective, if there are comments in the code, they're more likely to be a novice. So there are some interesting things that we can find in this graph. So discussion. So first, let's talk about ethics. So in the background section, I've mentioned that a possible application is for the pre-selection of job candidates. There are 3 main concerns: accuracy, efficiency, and fairness. Accuracy-wise, our model isn't particularly accurate, only 0.713, although we do believe that this could be improved. Efficiency, we do believe that this could help the company speed up the hiring process, but for fairness, we are afraid that there might be some bias in our model, and therefore the conclusion is that the model is not ready for deployment due to its low accuracy, and it has to be more thoroughly studied, especially trying to rid the final model of any bias. And further work could be done for a more general and larger data set to improve the accuracy and also make the model not just able to analyze solutions for the same coding problem. And also we could do more experiments on different features and models. And that's the end of our presentation.
Okay, so do you have questions on the YouTube channel? Okay, no questions on the YouTube. We have one question from the audience.
My name is Giuseppe Scagnello from University of Basilicata. Actually, it is not a question, but just a clarification. Can you provide further information on how you got the gold standard? So how do you classify programmers as expert or novice to validate your prediction model?
Yeah, so let's see. So the definition of novice. So we look at the LinkedIn profile, right? So they will list their work experience. If we do not see any programming related work experience, then we classify them as novice. And if they have any full-time work experience in the programming field, then we classify them as expert. Does this answer the question?
The audio is not understand your answer. Can you speak aloud?
Okay. So we look at their LinkedIn profile, and often they will list their work experience. So we look at the list of work experience that they list on the profile. If we do not see any programming related work experience, then we classify them as novice. And if we see any full-time programming related work experience, then we classify them as an expert. So yeah.
Okay, so I don't see any other raised hand from the audience. So I would go further because we are a bit over time. So thank you, Chiong, for your presentation. And now we can move to the next paper, which is a work by Klara Borova, Robert Bornik, and Andrei Zalewski. And the paper is named Is Knowledge the Key? An experiment on the biasing architectural decision making, a pilot study. So we have here Clara from Remote. So please, Clara, I leave the stage to you.
Okay, hello. Can you see my screen? Yes. Okay. Really? Can you see my screen? No. I can hear you. Oh, okay, I can see that you can see. Okay, so hello. My name is Klara Borova. I'll be presenting this is a short paper, a pilot study on the biasing architectural decision making. So first I will start about cognitive biases, what exactly they are. Then I will talk about our pilot experiment, the preliminary results, and the research outlook. So first, as definition, cognitive biases are predictable errors in the ways that individuals interpret information and make decisions. What does it mean exactly? So the basic idea is that the human mind is divided into two systems, system 1 and 2. System 1 is our intuition, is our unconscious reasoning. The problem is that it's unable to do rule-based mathematical reasoning. System 2, on the other hand, is slow. We have to consciously use it, and it's capable of logical rule-based reasoning. So how do cognitive biases happen? Here's an example. Let's imagine that a man owns a Ferrari car and he loves his car. So for some unrelated reason, he has to choose if he should buy Ferrari stocks. At this point, System 1 will tell him, oh, you love your Ferrari car, buy the stocks. That's his intuition. So if he makes a quick intuitive decision, he may buy the stocks. And this is the situation that we call a cognitive bias. On the other hand, he may also put in some additional mental effort and buy or not buy the stocks based on some more logical reasoning. It's important to note that when we talk about cognitive biases, we talk about the logic behind the decision, and we can go make a good decision for the wrong reasons. That's why here in both options, you can buy the stocks. So here's some examples from software engineering overall. So cognitive biases, for example, can cause developers to do overly optimistic time estimates for their tasks, or may make them create confirmatory tests. Confirmatory tests are those that check something that's already been tested. Or even during programming, for example, a developer may continually use some kind of data structure when it's not the most suited for the task, or reuse one's old project files when there are new fresh templates available. In architectural decision making, the various aspects can be influenced by cognitive biases. Some example may be an architect making a decision based on a presentation by a marketing specialist, or ignoring information about possible problems because of pressure from the client. Also, previous studies of ours shows that cognitive biases may cause the creation of dangerous architectural technical debt. So that's a reason why we want to prevent biases. Our research question here was, does educating software architects about cognitive biases provide the biasing effect? Simply, if we tell architects and developers about these problems, will it fix the problem at least partially? We chose 3 cognitive biases to research. Those were the ones that had, the 3 that had the greatest influence on architectural technical depth from previous study. The first one is anchoring. That's when one puts so much focus on one solution, idea, usually the first one that they came up with. In architectural decision making, this usually means that someone proposes a solution, the first one that they had in their mind, or they heard about it somewhere, and doesn't take any other option into account. Optimism bias is when there's it's the baseless optimistic assumptions. So, for example, this happens when a developer or architect doesn't take into account any risks of their decisions. And confirmation bias, that's the tendency to avoid information that contradicts one's beliefs. Usually in architectural decision making, this means the reluctance to change one's decisions after they were made, even if there is some information showing us that the decision was wrong and that we need to change it. This is only a small pilot study. We gathered data from 2 groups of graduate students. They were doing a project as part of their coursework. They had to get a requirement, design, implement, and test a project during the semester. We recorded 2 of the meetings from both groups. To one group, we showed a presentation about cognitive biases in architectural decision-making. We explicitly told them about those 3 cognitive biases that we researched and how they may affect their decisions. And we hoped that it would provide a debiasing effect and that their arguments would be more rational during the meetings. Here are our participants. Both teams consisted of 5 people, and most of them had professional experience in software development, with one exception. To analyze the data, we transcribed the recordings from the meeting independently. Me and the second author, we coded using this coding table on the left the transcripts to search for biased statements and arguments for architectural decisions and against architectural decisions. Then we met and we negotiated our coding, which means that if there were any differences, we talked about the differences until we reached a consensus on all of the codes. Then we counted the occurrences of the codes and also how much of the arguments and counter-arguments were influenced by the biases. So here are the results. So team number 2, that's the one that we showed our presentation. And as you can see, it was absolutely unsuccessful. So the preliminary results show that simply informing is not enough. But there are some other interesting contributions from our short paper. First, the arguments. So there are some observations that I will want to show. Firstly, overall teams were more likely to give arguments for a solution than against any kind of solutions. And even here in team number 2, the counter-arguments, most of them were biased. Here we have biases in the statements, in the arguments, counter-arguments, and overall in the conversation, those didn't affect explicitly in any arguments, those for the other statements. So one thing that I'd like to point out is that anchoring mainly influenced arguments. So mainly we anchored on the solutions that we proposed ourselves, even if it made not much sense. Also, counter-arguments were heavily influenced by confirmation bias. Those were mainly statements when a team member said, "Oh, there is a problem. This is a bottleneck in our system." But the team usually told this person, "Oh, no, don't stop being troublesome, don't worry, no, it's not that important. So counter-arguments were heavily influenced by confirmation bias in the second team. And overall, the other statements were heavily influenced by optimism and confirmation biases. This is the overall flow of the conversation. The teams felt a really big need to reassure themselves that their course of action is correct. So they often used statements like, oh, let's not worry, let's just start coding, everything will be okay, instead of analyzing any kind of risks. So here are those case observations that I just talked about. Taking those into account, we proposed 3 additional debiasing interventions. Those are some pretty simple practices that could be implemented in team meetings. The first one is against anchoring. So we want the person presenting a solution to also present at least one drawback. Any kind of decision has at least one drawback. We hope that this will bias the person presenting it. Secondly, against confirmation bias, we want one team member to monitor the discussion. In practice, this could be whoever is leading the meeting, a scrum master, for example, a manager or a leader, to monitor arguments that are influenced by confirmation bias. So those, oh, let's not change it because change is awful arguments. Thirdly, against optimism bias, at the end of the meeting, we'd like the team to write down the initial decisions and explicitly list the risks associated with those decisions. And of course, change the design accordingly. So in the future, we plan to repeat this experiment on a bigger sample, because 2 teams is not enough to say these are very, very preliminary results. We want to, instead of a simple debiasing presentation, also have a workshop where we will have participants try these 3 practices on simple tasks, so they learn them by heart. We also want to have groups perform 2 tasks, one before and after the workshop, so we can actually not only compare we can compare them how naturally biased the team was from the start to the effect after the workshop. And we want to add an additional code to the same decision, so we can count not only the quality of the arguments, but also how much the final decisions were biased or not. Here are my references, and thank you.
Okay, so do you have any question from the web? Okay, so if we have any raised hand from the audience. Okay, we have one.
Is Giuseppe Scagnello. Very interesting talk. If I'm correct, if I'm not wrong, I read in the text of one of your slides, IKEA effect.
Yes.
Or, what does it mean?
Oh, IKEA effect. It influences us that if we create something or put something from parts, like like the furniture from IKEA, we have this unconscious feeling that it's better than the thing done by something else. In software engineering, it may mean that if someone creates a solution or codes something, they believe that it's better because it's theirs than a similar solution done by someone else.
Thank you. Okay. You conducted a pilot, right? And also at the end of your presentation, you presented a number of future direction. But many of the direction you have outlooked in your slide seems in the short run. Do you have some future work in the long run?
Well, for sure, I want to do the short run to repeat this experiment on students, I need to see, and we need to have some kind of, well, positive influences, right, on the biasing before we propose this to anyone in the industry. I hope that after that these three practices will destroy the biased flow of the conversations from the students, and hopefully, if our results are promising, I would hope to find some industry partners and try to influence real-world projects in the future.
Okay, so we don't have any other question from the audience, so we can move to the next and last presentation of this session. So thank you, Clara, for your input. And now we can see the last presentation, which will be about a paper by Martin Hell and Martin Holst. And the name of the presentation is Communicating Cybersecurity Vulnerability Information, a Producer-Acquirer Case Study. So please, Martin, I leave the stage to you.
Thank you very much. I guess you can hear me, otherwise let me know. So thank you for the introduction. I will go straight to the introduction and to the motivation of our paper. So we base our paper on the fact that open source software is on the rise. And if you look at the recent reports from GitHub for JavaScript, they see that for 95% of the active repositories, they use open source software with a median of 10 direct and almost 700 transitive dependencies. And the transitive dependency is like a dependency of a dependency. And this can go on for several steps. Then we also have the fact that the National Vulnerability Database that collects information about vulnerabilities, there we can see that the number of vulnerabilities has increased very much, as you can see on the graph. So just since 2017 and until now, it has been like a huge increase in the number of vulnerabilities that we have. And also from a report by IBM, we can see that exploiting vulnerabilities was the top attack vector during 2020. And this amounted for 35% of all the incidents that they could see. So this is the background motivation for the paper. And another thing that we can see is that in a typical IoT setting, we have a producer or a manufacturer of IoT devices. And then we also have another entity that is typically the acquirer or the integrator of the IoT devices. So the producer, they create the firmware and they fix the vulnerabilities. But on the other hand, it is up to the acquirer or the integrator to actually install and update the new firmware that fixes these vulnerabilities. So since both these have a shared responsibility when it comes to fixing the vulnerabilities in the product, there needs to be some way of communicating security and vulnerability information between the producer and the acquirer. So the goal of our paper is to understand how considerations regarding vulnerabilities in these third-party components, the open source components typically that I talked about, how they arise, how they are communicated, and how they are assessed within and between a producer and an acquirer. We divided this into 4 research questions, where the first research question is what roles and responsibilities can we identify within the 2 organizations? The second one is how is vulnerability information communicated within and between the respective organizations? The third question is what decisions can be made and what information is used. And the fourth research question is what challenges and opportunities can we identify both within the organizations and in the communication between them? The methodology that we used is an exploratory case study, which means that we want to understand the situation and try to seek new insights. It is a qualitative study in the sense that we base this on semi-structured interviews. And a brief overview of how we did this is that we first defined a set of research questions. Then for each of the 2 companies, we had a company lead. And between the different interviews, we had discussions with the company lead in order to identify new people to interview within the company and maybe also adapt the coming interviews based on the result of the previous interviews. After that, we analyzed the interviews and then we extracted the challenges and opportunities that we could identify. So just very short about the producer and acquirer that we used in our case study. The producer is a producer of high-end IoT products with a focus on security. They're in the global B2B business. They are relatively old company, 30 years old, and they have about 1,000 employees. For the acquirer, this is an integrator of high security systems, and they sell these integrated products to their customers. It's a somewhat older company, so they have 80 years history and around 100,000 employees worldwide. The assumed information flow that we're going to use in our case study, and which was also validated together with the representatives from the companies, is that in the first phase, the questions regarding vulnerabilities arise in the acquirer's organization. Then the acquirers are somehow communicated to the producer. The questions are communicated to and from the answering role within the producer's organization, and then the answer is communicated back to the acquirer. And finally, the answer is communicated within the acquiring organization. So this was the typical case when the acquirer initiated the question, but we could also have the case when the producer initiated a preemptive answer. So it's not really an answer, it's just information that they want to send to their customers, and in this case, the acquirer. And then we start in step 4 in this information flow. So I will just go very briefly through some of the results that we have. For a more in-depth treatment, I refer you to the paper. So if we look at the acquirer side, we have a support team, we have a product owner, and then we have production teams in each country. And the production team that is one in each country, they will communicate with the customers, and these are the ones that are selling the product to the customers. Looking at the support team, this is centralized in one country, and they are responsible for identifying and prioritizing vulnerabilities. So when they come up with questions, or when they find information or find questions that they want more information on, they find this typically from 2 different sources. One is externally produced information. So this is information that they find, for example, on online forums, news and research articles that they monitor. And then we have also internally produced information, which is what they find from vulnerability scans that they do themselves on their own products or their own systems that they sell to their own customers. So they are frequently running like vulnerability scanners and network scanners to identify possible vulnerabilities in the products that they have. And then when they receive an answer from the producer's organization, they are also responsible for having a meeting to determine how to prioritize and how to get this new firmware update out to the end customer through the production team. And the production team, they are the ones that offer the integrated systems to the customers, and they are the ones that are responsible for deploying the new firmware to the customer systems that they are maintaining. There is also a product owner. This product owner defines the requirement, but is not at all involved in the specific discussions regarding vulnerabilities or security for the specific system. So this is completely handled by the support team and then propagated to the production teams. On the producer side, they have a first-line support, then they have product specialists, and they have a software security group. And also involved in this ecosystem, there is a release team and there is a set of development teams. For the first line support, these are the ones that receives the security related questions, and in a very large share of the cases, what they see is that they get a vulnerability scan report. So typically the customers are making a vulnerability scan, for example, through a third party like a consultant that they hire. And this vulnerability scan report is sent to the producer, and then they just ask what is happening here. Do we have this vulnerability? What should we do about the vulnerability? First line support see relatively few security questions in the total amount of questions, but still the last couple of years they have seen that the security related questions are increasing. The first line support can immediately answer around 70% of the questions, while 30% of the questions have to be propagated to the product specialist. There are also some key account managers that use first line support for the security questions, so they are not really allowed to communicate security-related answers back to the customers immediately. They need to go through the first-line support when it is related to security. And the first-line support is also the entity that communicates back if there is a round trip in the organization. The product specialists are the ones that have deep knowledge about the different products. They answer the questions that the first-line support cannot answer, so the ones that are propagated to the specialists. When they do this, they typically look in their email inbox to see if this question was posed before and if they have a previous answer that they can reuse and send it back immediately. If they don't, they typically go through the National Vulnerability Database to read more about the specific vulnerability that they question about and see how it affects the product. And the product specialists are also the ones that write the release notes. Then there is a software security group. These are the ones that are responsible for leading the security initiatives within the company. They're also doing triage of the vulnerability, that is trying to understand to which extent the specific vulnerabilities are relevant for their specific products and in the environment that they are deployed in. And the software security group, very rarely, but it happens that they have to answer questions that the product specialist cannot answer. And then there are also the release team and the development teams, where the release team are the ones that are making the new firmware releases in case there is a patched vulnerability. And then for the development teams, they are responsible for updating to the new versions. And they also have responsibility for monitoring new vulnerabilities for the components that they manage, so they can get immediate information about vulnerabilities. So just very briefly, the results for the challenges and opportunities that we found. So looking at the producer side, one challenge is that there is a very scattered knowledge. So there is no collective, or in some sense, not even an individual memory of previous answers. They were looking through the emails, as I noted previously, but there is no collected database or some information that they can use that is central, that everyone can use. So for example, different product specialists need answers to similar questions, and then they do it reasonably independently. And also we have the case that developers, since they are responsible for their maintained packages, they often knows about these vulnerabilities already. So one thing that we could extract from the interviews here is that this system could break when the company grows or with growing employee turnover. Another challenge is role-targeted security training. So first-line support are the ones that are always receiving the security-related questions from the beginning, but there is not much security training for first-line support from the beginning. And sometimes they experience that they, in some sense, panic when new vulnerabilities are queried. So if they see that this seems to be a very important vulnerabilities, they get a little bit of panic because they have a very shallow understanding of security in all, and also they have a very shallow understanding of the vulnerability reports that they typically get. Another challenge from the acquirer side is that they have a strong reliance on the producer. So the acquirer just relies on the release notes that they find, but this is very difficult if you have very many devices, very many different models, and also very many different firmware versions. And keeping track of all the release notes can be difficult in this case. Some opportunities here that we identified is on the producer side, that they could leverage internal scan information. So the producer is here doing their own internal vulnerability scans. However, this knowledge is not really transferred to first-line support. So when first-line support get these scans, probably some other team, for example, developer teams, they already know about these vulnerability scans and have all the information, but it is not really leveraged in the information dissemination within the company. And from the acquirer side, what they could do is that they could have a system for registering for release notes. So if they can receive release notes for the specific models of interest, that could make the information much more relevant to the acquirer. And to conclude, what we did here is that we conducted a case study to understand how vulnerability information is communicated within and between a producing and an acquiring organization. We have revealed a set of challenges and opportunities that we could identify within the two organizations. And even though these are very organization specific, they can still be considered also for other types of organizations. For future work, what we have identified here is that it would be interesting to better understand how does this information regarding security and vulnerabilities fundamentally differ from other information that is communicated. And it will also be interesting to see if we could implement and evaluate some of the optimizations that we have identified in our work. And that concludes the presentation.
Okay, thank you for your speech. We have no questions from the social platform, so if we have any raised hand in the audience. Okay. Okay, we have one.
My name is Giuseppe Scagnini. Thank you for your nice talk. I think that the topic you have approached in this paper is very important, and it is not so common to attend and to see presentation on the cybersecurity and software engineering, especially when this kind of research is conducted in cooperation with any industry. I was not able to see the name of that industry. I suppose that it is due to the confidentiality reason, I suppose. And so the first question is that, and you answered moving your head, so thank you. The second question is, I suppose yes for that, for also that other, for my second question. Did you share your results with the industry, with the management of that industry? And if yes, as I suppose, what is the feeling of the industry about your experimental results? And how this industry decided to act to deal with your delineated opportunities?
So by industry, I guess you mean the specific involved companies and not like the industry at large. So the people that we were talking with at the specific companies, they were in a management position. So the company leads that we identified, they were in a management position, and they were also very close to like higher management. So they, if I remember your question correctly, so how are they going to do, how are they going to handle this thing in the future? So what they did is that they have looked at, of course, at our results, and we have discussed it at length with them already. They really want to implement some of the things that we found and try to fix it in their organizations. I think the main reason that they have not done it so far is because of the COVID situation, and they're still working remotely. But we have as a future plan to follow up on what they are doing and to further discuss this with them, because we have very close cooperation with them and are working currently with them still. Did that answer the question?
Okay. So I think that we can close this session and this presentation. So thank you, Martin, for your contribution to this conference. And I say that this contribution closes the third session, and we will be back after a short coffee break in about half an hour from now, 20 minutes from now. Okay, thank you.
All right, everyone, welcome to the last session of this conference. I will be acting as a session chair. My name is Tommi Mikkonen and I come from Finland, University of Jyväskylä and Helsinki. The first paper we are having in this session is capitalizing on developer-tester communication, a case study.
Hi, so I'll share my screen first. So I hope everyone can see my screen. Hello, can anyone hear me? Hello, can I get a confirmation if anyone can see my? Oh, okay, thanks. Okay, so I'm Prabhat Ram. I'm the lead author of this paper, Capitalizing on Developer-Tester Communication, a case study. So first, a bit of context that motivates this study. So as part of an ACE 2020 project called QRapids, we had collaborated with 4 software-intensive industries to help them establish a metrics program to aid in their data-driven decision-making. Now, these metrics help these companies monitor and utilize their software development data in their daily activities, particularly structured data. Now, these structured data can be easily represented in tabular forms. You find these in relational databases. So for example, date, issue type, effort estimation, bug severity, etc. These are all examples of structured data. Now, the metrics program targeted these data at the companies that they collected using diverse tools like Jira, Jenkins, Gerrit, GitLab, etc. Now, however, it's estimated that about 80% of data that's produced in modern software development is of unstructured type. So these data are free-form data expressed in natural language. For example, customer comments, user requirements, feedback, etc. are all examples of these unstructured data. Now, these data were never targeted by the metrics program that were established at these companies because it's quite difficult to quantify such data without some sort of smart pre-processing. And also such data tend to be heavily loaded with development context, which is something that will be lost if we were to quantify them in order to make it suitable for a metrics program. And also literature suggests that these unstructured data hold tremendous amount of software development insights. And knowing these insights can actually help practitioners engage in more data-driven software development. So throughout the QRapids project, we focused on only the structured data, while approximately 80% of the unstructured data remained unutilized and unexplored. So in order to explore such data and gather potential insights that these data may hold, we targeted the unstructured data from SoftTeam. This was one of the industrial participants in the project. So the practitioners were kind enough to share whatever data they had collected during the project. Their unstructured data concerned communication between the developers and the testers during the development of one of their flagship products, which is a modeling tool called Modelio. Now, this data was stored in a bug tracker called Mantis, which is similar to Jira. This tool stores something called issue description, which captures issues as in problems, defects, bugs that are reported by the testing team and even the end users. And developers respond with a fix for the said issue, while the testing team uses to resolve the issue, and the outcome is captured in another column called test feedback. Now we wanted to analyze these data to see what insights they hold. So naturally, the research question that we formulated was, what software development related insights could be discovered from the developer tester communication at the case company? So now we had the data, and all we needed was a suitable technique to analyze that data. Now, this is where the text mining technique of LDA comes into the picture. LDA stands for Latent Dirichlet Allocation. Now, this technique takes a collection of documents and mines the text for underlying patterns. These patterns are what we call topics, which basically reflects the different themes that these documents exhibit. Here, the term document could mean a couple of lines of natural language text, a paragraph, a chapter in a book, or an entire scientific article. Each document can have multiple topics, and each topic is made up of multiple words and can be present across multiple documents. Now, LDA leverages how we use natural language and identifies topics by picking words that co-occur frequently. Words that co-occur frequently are likely to be semantically related. Now, the picture on the left is an example of how different topics can be extracted from a document, which here is about genetics. And the topics that LDA extracted were it also concerns neurology, IT, and evolutionary biology. So the LDA's potential to retain the implicit semantic relation among words is why it's so popular. It's one of the most popular techniques for analyzing unstructured data. And this technique has already been used to analyze source codes, requirement documents, bug reports, commit messages, and even email communication among developers. So with this knowledge, we used LDA to explore the developer-tester communication data from Softie. Now, we weren't expecting much because of a rather small data set. However, the results pleasantly surprised both the researchers and, more importantly, the practitioners that we collaborated with. So we applied LDA to the 3 data sets from 2016 to 2018 separately and shared the results with the practitioners to identify topics and make sense of them. This is the result from the 2016 issue description dataset. There are 6 topics here with no labels because LDA by default does not provide labels. The practitioners had to propose those as well. Now, each topic here is a collection of words which co-occurred frequently enough to be clubbed together under one topic. So the practitioners looked at all these keywords and they came up with these labels. Now, these labels demonstrate the different issues or different categories of issues that were reported during the development of Modelio in 2016. Okay. So as I mentioned earlier, we also targeted unstructured data from another column called test feedback to learn more about the issues that were reported under issue description column and what insights the practitioners could infer from all that information. So here we basically joined the keywords from 2016 test feedback corpus, from 2016 2016 test feedback corpus with the topics that the practitioners inferred, which I talked about in the previous slide. And then I asked the practitioners to judge if there's any pattern that they can discern, and they did. So the collaborating practitioners were the product development team lead and the R&D head from Softie. They claimed that these topics highlighted major work done on stabilizing their product's core components. And then there were several non-development related anomalies relevant to the product's core components, as well as development of new features. Overall, these topics revealed development process themes that could not have been discovered from other sources. In summary, the 2016 topics provided evidence of development activities to improve their flagship product stability, particularly internal stability. What we did for 2016 corpus, we repeated for the 2017 and 2018 dataset as well. So the 2017 results reflected that bulk of development activities was centered on addressing issues reported by the end users, a trend that was continued in 2018 as well. The development activities addressing end user reported issues and general product quality are typically part of the company's background work, and they are difficult to assess over time as they are unplanned and therefore not monitored. LDA helped make all that information explicit. Moreover, the practitioners claim that put together, these topics demonstrate an evolution in the development process, starting from addressing the product's internal quality in 2016 to transitioning to addressing external quality in 2018. They qualify this claim by saying that the observed evolution is quite natural. However, it is something that they never would have discovered based on their traditional practices and sources like retrospective meetings or project plan. So the key takeaway here, as illustrated by a non-exhaustive classification that we proposed as part of our findings, are as follows. Thanks to LDA, the practitioners gained an enhanced visibility into their development activities, where they first focused on just the product's internal quality and then the external quality, which, when put together, demonstrated software development process evolution, albeit natural but still very difficult to detect using the regular tools available at companies' disposal. As a result, the practitioners are now convinced of this technique and would like to incorporate it in their regular development process by analyzing their data on a regular basis. And access to this nuanced historical data allows the practitioners an understanding of how their software product and process evolved, which they can now account for in their future planning and development of their flagship product, Modelio. And with that, I end my presentation. Thank you for your time. I'm now open for questions and comments.
Any questions to the speaker? Well, I was actually surprised by the fact that the more you went towards today, the less and less it seemed that the discussions implied new feature development and more about the getting into the immediate issue. So is this a correct interpretation? What does, I mean, in a way, this also might indicate that the project is at a certain end of or at a certain place in a product life cycle. So how would you describe that? That you have.
I'm sorry, could you please repeat that?
I was surprised because you say that there is almost no new feature development.
Yeah.
In 2000.
Yeah.
Because everybody was so busy fixing end user issues, or because the product has all the necessary features already.
Yeah, that's a possibility. However, the thing is, for throughout those 3 years, they had released 3 different versions of the same Modelia tool. So one possibility, like you stated, is that enough features were already developed, so all they had to do was work on the issues that were reported by the end users. However, the practitioners did not find that distinction, and they simply claimed that all the new features that we required for a development were already worked on in 2016 and 2017, and 2018 primarily centered on just improving the overall quality of the tool that they produce, as well as addressing as many issues that the end users raised.
Okay, thank you. Any further questions? All right, let's thank the speaker. The next paper is analyzing safe practices with respect to quality requirements, findings from a qualitative study. And we have the presenter here, so this is a true live event.
What did I do? I don't see the presentation. Yes. Good evening, everyone. However, when I look at your faces and attitude, I think maybe good night will be more suitable. My name is Wasim Asakaf, and today I'm going to present our result regarding SAFE and the treatment of SAFE regarding quality requirements. I will start with the introduction, research question, research process, results, traits of validity, and at the end I will conclude the research. As you know, agile methods became the last years very popular. A lot of companies use agile to gain the benefits promised by agile methods. However, the most agile methods were designed in the first place for one team, co-located teams that work on one small project. Many big companies the last year use also agile methods to see whether it will be suitable for their projects. But many studies found also that adopting agile methods within large-scale projects doesn't go flawless. Many studies report the neglect of quality requirements in big agile projects. When I say quality requirements, I mean non-functional requirements like security, performance, maintainability, etc. We initiate a research project to see how we can treat quality requirements within a large-scale distributed projects. As part of our research, we have defined 15 challenges, quality requirements challenges, large-scale project cope with. And then to come up with responsible solutions, we first look at what kind of solutions are there that we can use to cope with or to solve the challenges we have defined. The first place we look at is the agile, large-scale agile methods like SAFe, LESS, Scrum at scale, and we investigate what kind of solutions they have to respond to those agile quality requirements challenges. Our presentation today is about SAFe and the practices SAFe has to offer to use to cope with those quality requirements challenges. So we want to know what kind of practices SAFe suggests to cope with the challenges we have identified previously. Those are the quality requirements challenges we have identified previously and published. We categorize them into 5 categories. The first one is teams coordination and communication challenges. The first category, as example of that of this category, the late detection of quality requirements invisibility. The other category is quality requirements elicitation challenges, and then quality assurance challenges, conceptual challenges of quality requirements, and architecture challenges. Due to time, I cannot go through all those challenges, but if you are interested, you can read the paper. Those are the quality requirements challenges we have identified. The current paper, as I said, it's about a SAFe framework, and the practices SAFe, the SAFe framework offers to deal with those challenges. So we implement, Our research question is, what are the agile practices suggested by SAFe that could mitigate the effect of the quality requirements challenges we have identified? To answer these questions, we divided the questions into 3 sub-questions. The first one, which SAFe elements described in the SAFe textbook and related literature could possibly mitigate the quality requirements challenges we have defined previously. Here about what the SAFe authors actually think about their practices and how they think those practices could solve the challenges. And the second sub-question is, do SAFe practitioners experience the quality requirements challenges we have identified? And if yes, how do they deal with that within their implementation of SAFe, of the SAFe framework? As we see, we have here 2 parts. One of them based on documentary research, while the other one is based on a case study. So we developed our research. The first 4 steps. The first step is documentary study, where we studied the literature of SAFe to see how SAFE treat those quality requirements challenges. After that, we made some assumptions about how we think that SAFE could solve those challenges. And the third step, we conduct multiple interviews within industry to see how the SAFE practitioners deal with those challenges. And at the end, we compare the results from both studies. The documentary study, the second author of this paper and me, we studied the papers, we studied the books of SAFE, the last version, and we studied also the website of SAFE to see how SAFE deal with those quality requirements. We did that. We did this study separately, and then after that, we discussed our results together and come with a mapping that we think the right mapping when we map the SAFE practices to the challenges we have identified. The second study, we did a qualitative exploratory study. We did 9 interviews within 2 big organizations. We select participants from these 2 organizations based on criteria we have defined. So each participant should at least have worked in the IT for at least 10 years and has at least 3 years experience with SAFE. And all participants should have worked with quality requirements, and of course, they must be willing to give this interview. The interviews, in-depth interviews, each interview, we conducted each interview within 1 hour in English and in Dutch. We recorded the interviews, transcribed them, and then coded them. And after that, we also mapped the practices we have identified from industry to the quality requirements challenges we have defined. The interviews we did into 2 big organizations. The first one is a government organization within the Netherlands, about between 30,000 and 100,000 employees. The second organization is a multinational consulting organization located in India. Has more than 100,000 employees. From the first organization, we interviewed 4 participants in Dutch, and from the second organization, we have interviewed 5 practitioners in English. We choose also to have practitioners from different with different roles, so to collect multiple perspective. So we had a technical lead, we had an agile coach, solution architect, agile coach, project managers, IT managers, product manager. So we can see different roles from with different experience in IT and in agile from 2 organizations. What we have found from the first study, the documentary study, we have identified 25 SAFE elements that could be used to mitigate the quality requirements challenges. Some of those practices could mitigate 1 or more challenges, and we also have found also that 1 challenges could be mitigated by 1 or more SAFE elements. We also found that SAFE doesn't explicitly specify a particular practices that could mitigate the following challenges: lengthy quality requirements acceptance checklist, and a confusion about quality requirement specifications approaches. Those two challenges, we couldn't find SAFE practices that could be used to mitigate them. The second study with practitioners, practitioners have identified 9 safe elements that they use to mitigate the quality requirements we have identified. Each of them could mitigate one or more challenges. Also, practitioners didn't explicitly specify particular safe practices that could mitigate the challenges: late detection of quality requirements, infeasibility, and the lack of cost-effective real integration tests, and overlooking sources of quality requirements, and the last one, unclear conceptual definition of quality requirements. What we see that there is the contrast between literature and implementation. We see that practitioners do not implement SAFE in the way it was explained in its book. It could be because of the complexity of SAFE. SAFE is a very complex framework, and SAFE also borrows a lot of heavy elements from non-agile environments. And what we have also found that SAFE treats quality requirements as constraints on functional requirements. So each functional requirements has some constraints as quality. And we saw from previous studies that other companies treat quality requirements as standalone requirements, so not as constraints, but as standalone requirements. This problem we have also identified in our previous study as one of the challenges, the conceptual definition of quality requirements, whether they are constraints on functional requirements or they are on standalone requirements, because for each way, you will approach different way of working. Traits of validity, type of documents and their reliability. We use, there are a lot of books, papers about SAFE, but we choose to use the official book of SAFE that is published by its authors, and we also used the official website of SAFE, so we don't think that is a treat actually for our research. Second one is the first and the third authors, so me and the third authors are an agile practitioners. We are from industry and not from a university. Biases could be introduced in our research, but therefore we discussed every step we did with our two scientific researchers, the second and the third author of this paper. They are prominent, well-known actually researchers in this field. Generalization difficulty due to limited involved organization. Yes, this also could be a treat, because we involved only 2 organizations. However, they are very big organizations. One is a multinational organization with a lot of experience in SAFE and in IT. And the other one is a government organization, also a very big one. So in somehow we can generalize our results to organizations that are similar to the organization we have used in our research. Also, we interviewed practitioners with different roles. So we did that to collect as much as possible perspectives of different perspectives from practitioners to give our research a kind of to cover multiple roles and multiple perspectives. Our conclusion, we studied SAFE with respect to the quality requirements challenges we have identified. Based on our documentary study, we've identified 25 SAFE practices that could be used to mitigate the challenges we have identified. And we did also an interview-based study, and this study revealed 9 SAFE elements that could be used to mitigate the challenges. There is difference between what the SAFE explains in its books and literature. Then difference between what states what is in the books of SAFE and the implementation of SAFE in industry, and that could be explained by the complexity of SAFE. Is there any questions?
Any questions from the audience?
Hi, so maybe not a question, but maybe a remark regarding your treats to validity. So you have looked at this official documents of SAFE.
Yes.
And have there, what you also said a little bit as a threat, that it might be not the best one just to look at that. So what is currently just getting more and more done is like looking at some kind of gray literature reviews where we just basically crawl some kind of Google results in a somehow systematic way, like 200 for some search string where SAFE is inside, and then get those view from practices after eliminating something. Do you think that might be also a possibility for yours, that you find also maybe other things? So because currently you have the mapping between, like you have said, how it should be in the documentation and how the practitioners have worked on that. But maybe when you raise the first one also to practitioner knowledge, which is directly used, maybe that could also somehow extend your results.
I didn't answer the question very well, I think. Can you explain more what you mean?
Maybe I can have another way. Do you think when I'm searching on Google for SAFE practitioners, so from some practices for SAFE, I found also more interesting results which could extend your approach?
First, we didn't use Google. For the first study, documentary study, we used only the books and documentation written by the authors of SAFE, because we want to know exactly how they think that SAFE could solve those challenges. So we want first to understand what the authors of SAFE thinks about those quality requirements. Searching in Google, it could be, but we have a context. So we want to interview people within our context. We don't. It's difficult to just go on Google and search for people that shared the same experience as we, and it's also doesn't give us a way to go in discussion with them to understand how they think. So yeah, now Google we didn't find to be a suitable way actually to answer our questions.
Hi. First of all, thank you for the talk. In addition, I have another question. Do you plan to extend this study, for example, through a web survey or everything else?
What?
Do you plan to extend this kind of study, for example, through a web survey?
We did. We actually we did already studied. We studied less large. Scrum. We studied Scrum at scale, so we already studied a couple of frameworks, and in this study only we focused on SAFE, and a survey is a way of doing research, and because we want an in-depth knowledge actually, so a survey is not suitable for us. We interviews give us a way to ask questions and to go further on the answers, while surveys, it's not survey. No. This is the only way that you For our study, for the kind of information we are looking for, is interview more suitable. Yeah.
All right, let's thank the speaker one more time. The next talk is toward the technical debt relationship with the pivoting of growth phase startups. And I guess this will be an online presentation. Yes.
Yes. Great. Hello, everyone. Good evening. I hope you can hear me well, and you can also see the presentation. The presentation is, as mentioned, toward the technical debt relationship with the pivoting of growth phase startups. And my name is Orges Chicho, the first author of this paper, co-authored by many other authors in this case, that I would like to thank for their participation in this research, which has been extensively conducted from several institutions like University of Oslo and, of course, NTNU, where I'm residing, Rice Institute, USN, and UFBA in Brazil, as well as Chalmers University. So a brief outline of this presentation starts with a bit of introduction on how this study has been conducted and what motivates us to conduct this study. And then we'll move towards the research background, methodology, and results, and of course, conclusions and future work for our research. So first of all, we have analyzed what is the feedback about pivoting for startups, which means that it's a strategical tactic for startups usually to change directions in their implementation and their...
So can you please go to presentation mode? We can see your PowerPoint in the outer mode.
You don't see it in presentation mode? How about
Can you
now?
Please, can you switch from Firefox to Chrome? Because the sharing is frozen. Like.
Okay, let me upload again then. Okay, just give me just 1 second. Share slides, and I can share this. Is this better? Hello, is this better? Yeah. So I'm sharing the file now, so I think it should be okay. So to go back to the argument, pivoting is a strategical tactic for startups, and the shifting course of actions usually becomes either to change the business model or adapt to environmental changes. And the main idea or the main clue for this research was that it was not clear how technical debt might lead to the pivoting scenarios. And of course, we looked at the relationship between technical debt and pivoting in growth phase startups in this case. So research background. First of all, we found that there are several studies which are addressing from early to growth phase startups pivoting dilemma, and same applies to the technical debt. But the problem is that we don't really know what is the collaboration between the two, or what is the impact between the two. So we have to explore this dilemma that we have in this case. What we used as a methodology is based, starting from our two main research questions, how technical debt influences pivoting in growth phase startups, and how are technical debt processes associated to pivoting types in growth phase startups. So what we did was to start a qualitative investigation based on mainly grounded theory, and we interviewed several practitioners in this case from different startups, and we took a qualitative approach by analyzing the data based on open coding and thematic analysis. And based on our themes and categories created in this case, we were able to start and identify some key findings, which helped obviously answer our two research questions, and furthermore helped us state a little bit more hypothesis for future work. So the case selection for the startups was primarily based on the fact that the startups were solid and they were in growth phase, which meant that they should have been operating for up to 5 years, but they had at least received some stable income in this period of time. And also they should have entered the growth phase in the last 2 years, which meant that they didn't linger so much within scaling as startups, which it is not the case for tech startups in general. And also they should have had return positive incomes, as well as the development team should be larger than 4 participants, which meant that they were really doing some good practices either in agile or software development in general. So from our cases, we were able to select, or at least we were able to interview, in this case, 11 startups, where 7 of those startups resided in Norway and 4 others resided in Brazil. And from the perspective of what the startups were doing, there were mainly technological startups, and we could talk to the CEOs or CTOs of the corresponding cases in this matter. However, I have to note that all CEOs and all CTOs in this case, especially the CTOs, but CEOs are also involved in the development team, which meant these are not CEOs that didn't understand software practices. So they were very keen on software practices, and they had hands-on experience. The interview design was mainly split in 3 parts, where the first part was about the background and demographic of the startup in general. Then we moved on towards the software and technological aspects by asking questions how they develop their software and how they actually achieve their results. And the third part was actually focused a bit longer, which also focused on our research questions, was focused on the perception of technical debt and the relationship to the pivoting types. So 2 main questions in this part were like, how have you coped, for instance, involving 4 processes that we call, such as ignore, accept, avoid, or manage technical debt, with while transitioning from early to growth phase. And the second question was about how has technical debt affected the pivoting, by selecting one or more of the 10 pivoting types within the software startup transitioning from the growth phase in general. And all was transcribed and recorded afterwards for purposes of achieving the results. So the steps here about the transcription were mainly to read after the transcription has been performed, read the different transcripts, and then starting coding and creating the different themes, so that we could understand what was in common and what was different in these cases that we are analyzing. Finally, we labeled those themes and connected them throughout a certain result map where the open coding could tell us a bit more. So the resulting map was mainly focused on technical debt and pivoting relationship in this case, and we were able to identify, for instance, manage and avoid TD, but these were based from the different processes. Like we have another paper where we explicitly state 4 different scenarios for startups, how they can cope with TD. But in our case, we could identify that only manage and avoid TD were the ones that the actual startups were doing in order to connect them to the pivoting types. But what was more interesting, and actually answering our primary question, was that what was the influence of the technical debt in general in the different pivoting types. And we could identify 3 scenarios, like direct, indirect, and no influence. And I'll go a little bit how this connected with the different pivoting types by stating which were the key takeaways in this case. So first of all, when we say TD is directly influencing pivoting, what we meant was that technology outdate, for instance, certainly leads to technology pivot. And this was something that almost all practitioners admitted. And then TD also, or technical debt, can also lead to technology pivot long before this outdate of the software comes visible. And the main reason is that startups will continuously struggle to accommodate new product features, which was something that happened quite often in early phase, but it wasn't also neglected in the growth phase of the startup. And when it comes to indirect influence of pivoting from the technical debt perspective, we could find that technical debt can hinder the startup software development in general, and or the product growth capabilities, which meant that even though it was not a direct affection from technical debt towards pivoting, we could still see that the technical debt was being a contributor in this case, both to technological and non-technological aspects of the pivoting in particular. Then there were cases where the startups couldn't identify, for instance, any influence from the technical debt towards the pivoting that they had performed. So in this case, the practitioners, like this was about 30%, the practitioners were discussing that we didn't really pivot because of technical debt, but because we had either other influences that made us pivot during our life cycle, especially in the growth phase. When it comes to the second research question, where TD processes that we call in this case relationship to pivoting scenarios, we could mainly say that managing and avoiding technical debt actually significantly reduced the likelihood of technology pivoting in particular, but not all the other pivoting types. And in this case, we can consequently say that restraining these effects on other indirect of TD in pivoting might be the case if startups do a very good approach in managing and avoiding TD. So after getting some insights from the results and being able to answer our research questions, we were a bit motivated towards stating a bit further this research by unfolding the following 5 hypotheses. First of all, we could say from the first hypothesis that the influence of technical debt on technology pivot is direct and unequivocal. And there is the need for more data for this, for corroborating this hypothesis, but we assume that in the long run, we would see that technical debt obviously will lead to some technology pivoting, and this will have a direct effect. Second hypothesis was that technical debt accruing or accumulating leads to technology pivot at some point in time, even though the startups were actually doing well and perceiving that they are doing well, but they are still accumulating a lot of technical debt, which will lead to that pivoting scenario anyways. The third hypothesis states that technical debt has an indirect influence on both technological and business pivoting, which means that even though startups might not notice the immediate affection from technical debt to their pivoting scenarios, they will be affected at some point in time, either from a business perspective or from a technological one. And technical debt is not related to business or even pivot types. This is something that might be on the contrary to the previous one, but it still needs to be corroborated in some of the cases, since we found that 30% of the startups didn't really connect technical debt to pivoting. And the last hypothesis is connected to the different perception of technical debt or processes on how to cope with technical debt. So managing or avoiding technical debt reduces its direct or indirect influences on various pivoting types. So 2 main conclusions from our study. First of all, startup research has sufficiently matured in categorizing separately both pivoting and technical debt processes, but the relationship between the two is weakly studied. And what our study is arguing is that we need more research in this context. And that's why it's towards a statement for other researchers and the community to look more into this relationship. And we observe that the relationship is sort of orthogonal, but it's also very deeply connected in this case, and which means that new theories might be involved in the future while investigating the technical debt and pivoting relationship. Finally, some future work we foresee, which comes also from some weaknesses of the study. Of course, these results cannot be generalized as much because the sample size is still limited, but still it makes a lot of sense to state some hypotheses based on the early qualitative investigation. So more surveys and interviews are needed in order to corroborate the hypothesis we state, and we need also to be aware of the fact that more studies could lead to different directions as well. And what we want to achieve maybe in the future is to provide a clear roadmap and guidelines so that other researchers and practitioners can exploit in the future, which means that technical debt and pivoting seems to have some good connection, but we need to still provide the actual categorization and even further detailed roadmap so that practitioners and especially researchers as well can make good use of this relationship in the future. So thank you very much, and I hope there are any questions. And even though I couldn't hear much feedback from my side so far during the presentation.
Thank you. Let's thank the speaker. So any questions for audience? Well, I, for one, now that you mentioned technical debt and startups in the same sentence, I have a feeling that this is a wider phenomena, so that many of the ground truths of software engineering we have originate from really big organizations. And rethinking them in a setup where the uncertainty is daily, you must make big decisions based on very, very limited knowledge and things like that. So do you think that it would be fair to categorize that we should partly think about the whole software engineering and not just technical debt differently in the context of startups?
Yeah, that's a good question, actually. The study here focuses actually on three concepts. The concepts are, of course, startups and technical debt, but it's also the connection to the pivoting scenario that the startups face. So from a larger perspective, I agree, software engineering practices in general from startups should be better understood, and they have been well studied in early phase, but not so much studied in growth phase. But when it comes to the relationship between technical debt and pivoting, we really saw a gap in this case. All authors agreed that this is a good direction to bring to the community. I agree with you in a certain way that it should be a bit broader to software engineering, but since the technical debt and pivoting was the main research question in this case, then I feel that the relationship has been somewhat explained in this research so that others can continue and progress with the work.
All right, thank you. Any further questions? If not, then let's thank the speaker one more time.
Yeah, thank you very much.
And then we shifted towards a common testing terminology for software engineering and artificial intelligence experts. And I assume this is an online presentation. Yeah, please.
Hello everyone, I'm Lisa Jöckel from the Fraunhofer Institute for Experimental Software Engineering, and I will give you an insight into some work on the terminology in software and AI testing. It's a joint work of participants from Fraunhofer and the University of Kaiserslautern. For a classical software component, the intended functionality is defined by a specification and implemented by a programmer. To check for functional correctness, classical software testing approaches can be used here. In case of a data-driven component, however, the functionality is provided by a model that is derived from a data sample via a learning algorithm. As there is an inherent uncertainty in the outcomes of such a model, we cannot expect to always get the intended outcome. Therefore, we rather want to show that the model has a good enough performance in a probabilistic sense. This is commonly determined by a statistical testing approach, which means that the data-driven component is applied on a test dataset that is representative for its intended application scope, and the results are then evaluated using a metric like accuracy or false positive rate. Testing such a component raises various challenges, like having only a limited specification and a model that is rather difficult to understand internally. Therefore, this raises the question if the use of other testing approaches is appropriate here. Due to the data-driven nature of these components, we see the need for adapting classical testing approaches and even develop new concepts. There we see the potential to make use of the experiences and well-elaborated approaches from classical software testing. Therefore, exchange and a deeper understanding between both fields are important. A major obstacle thereby are the different terminologies that are used in both communities. Let's have a look at an example. Here we have a classical software component and a number of test cases, for which we get a test result each. Either the test case passed or it failed. The test results are then aggregated into a test summary report, which shows that we have one failed test case. Based on the failed test case, we localize the underlying fault and fix the software component, leading to some change somewhere within the code. We then run the test cases again, and let's say we succeeded in fixing the component and therefore all test cases passed this time. How does this look like for a data-driven component? As test cases, we have data points that contain the model inputs and the expected outcome. These data points build the test data set. We then determine the test results on the test data set based on some evaluation criteria like correctness. These results are then aggregated using an evaluation metric. For example, here we have an accuracy of 93%. Which we consider as too low for this example. So while this approach might have revealed an insufficient behavior, it usually does not provide information on how this behavior came to happen. For example, it might be due to the choice of model hyperparameters, insufficient training data, or the training process. So it is not really clear which development decision led to a specific incorrect outcome, which might then be used for fixing the component. So what is usually done? A new version of the data-driven component is built with, for example, an extended training dataset or another model architecture. For testing this new model version, we additionally need to acquire a new test dataset. This avoids that knowledge of the later test data is already incorporated during the development of the model. We then determine the performance of the new model version on the new test dataset and make a decision if this is sufficient. The presented example is part of a mapping between basic workflows and some important concepts in software and AI testing. The mapping includes testing terms and example instances for the terms. The classical software component has the task of calculating the next gas station if the fuel level drops below a certain threshold. The data-driven component is tasked with classifying traffic sign types on images of traffic signs. Also, differences between the workflows are highlighted in the mapping. For AI testing, we might have a different concept, a different term, or concepts from software testing that are mostly not considered for data-driven components, but might be beneficial here as well. In the context of this paper, we focused on functionality testing on the level of the component, and for the data-driven component, we considered a supervised model. With this mapping, we want to support the building of a common understanding between experts in software and AI testing. Another intention of this paper is to encourage discussions between both fields. There are a lot of open issues in the field of AI testing that might benefit from the extensive experience in software testing. For example, when using unsupervised or reinforcement learning, because there is no ground truth information, or when testing a software system that contains one or more data-driven components. Although there are other concepts from software testing that might be considered for AI as well. From our perspective, another big question is how evidences from testing should be understood. In classical software testing, our objectives are to provide confidence and to find weaknesses in order to improve the component. Each failed test case can be used to debug and fix the software component. For AI testing, the objective is to provide confidence in the component. All test results together can provide information if the component performs well enough, but a single test result hardly gives information on how to fix the model. So what do we need to consider when arguing that the performance of the data-driven component is sufficient? Contrary to classical software, we won't get the case that all data points from the test dataset are predicted correctly. To summarize, we propose an intensified collaboration between experts of both communities, with the goal to create a common communication basis which would help to transfer and assess testing concepts for data-driven components. Found in the presented paper. Also, if you are interested how AI test evidences can be integrated in a safety argumentation, have a look at the other two references on the slide, or feel free to contact us. We would be happy to get feedback and the opportunity to discuss with you. Thank you.
Do we have the speaker online? Yeah. Any questions from the audience?
Can I talk? Yeah. Thank you for the presentation. My name is Giuseppe Scagnello. I have a very short question. What about the flaggy test?
Thank you for the question. Could you elaborate on that?
If you have a flaggy test is a test that sometimes fails and some other time does not fail. It fails apparently in a random fashion.
Okay, I would see that as related, but we haven't thought of it so far.
I thank you for a very enlightening talk. I think that this is one of the key things that we should fix, so that instead of one speaking of anomaly and then one speaking of failure, we would come to an agreement that how AI and software engineering would be a better fit together, so that we can build error-free systems. So thank you once again. And this brings us to our final talk, called Towards RegOps, a DevOps pipeline for medical device software. And the speaker is Henrik Toivakka.
Hello, my name is Henrik. I'm here to present our paper today, toward RegOps, a DevOps pipeline for medical device software. So my co-authors are Tuomas Brandon, present here today, along with Timo Poranen and Zheng Zhang from Tampere University. First, we start with background and motivation for this paper, what drove us to write this thing. So medical devices are strictly regulated in European Union region, and the recent introduction of medical device regulation changed the regulatory landscape for medical software-based medical devices in the European Union region a lot. So currently, both standalone and embedded devices must be classified under the same rules as physical devices. And also any existing devices that could be now considered medical devices must be reclassified under the new rules. In addition, the product must fulfill a set of regulatory requirements and bear a CE mark to be able to be sold in the EU region. On top of that, we also need to manufacture the medical device under a rigid development process that must comply with the regulatory requirements. The common challenges that this brings are the strict manufacturing process requirements, comprehensive documentation, testing, and traceability requirements, which Vlad was also talking about. He also explained them more detailed manner than I will, so we can save some time on that. And also we need to validate the medical device products. We see that this brings some contradiction to agile software development and the DevOps culture, which we are a fan of. And our goal in this paper is to introduce ways which can make the medical device software a bit easier and efficient. And we want to focus on the product instead of the extensive documentation and the rigid processes that the regulation brings. So now we go toward RegOps, and you might ask what RegOps is after all. So we see it as digitalizing the regulatory value chain, which in our paper means that we try to combine the process efficiency and the automation capabilities of DevOps with the regulatory requirement compliance. And our goal is to improve the lead time of software delivery while maintaining the regulatory compliance. So here you can see a picture I made. So how we did this? First we needed a reference DevOps pipeline model, and we had three options. We had model from Google, model from Humble, and model from Microsoft. And we decided to go with the model from Google. It's on the slide. We found that the model was most suitable for our use case. The second part was to choose the standards which we want to analyze for the DevOps pipeline. So the most convenient way to understand the regulatory compliance is to follow standards, because the regulation is too difficult to bring into practice. And we chose the standards 62304 and 82304-1, which affect the DevOps pipeline the most from our experience. There are also other standards you have to follow when manufacturing medical devices, but we felt that these were the most important ones for this concept. So what we did, that we collected the requirements as the numbered clauses from the standards, and then we put the requirements we analyzed into three different categories. And they were: one, the requirement can be implemented in the pipeline; second, it may be partially implemented in the pipeline; and third, it must be excluded from the pipeline, which essentially means that it still must be implemented by the company manufacturing the devices, but it doesn't fit into our pipeline. So the requirement must be implemented outside the model. After that, we map the requirements into logical stages called gates, which we are going to next. So here we can see the gates that we identified, and they contain various activities from the requirements, and we see them as barriers that the software change must go through before it can enter the next gate. We finally integrated those gates into our pipeline, which I will show next. But before I could explain something what these do. So first we have the developer, and he does the code checking. And after that we have the continuous integration gate, which triggers automatically, and it runs some automated testing activities, verification activities, static analysis, stuff like that, and it can be run repeatedly on the code changes. After we have something ready, we go to the review and verification stage, where we verify that all the changes are done appropriately on the software. After the changes have been verified, we go to the deployment pipeline, which doesn't contain actually any regulatory requirements, but we saw this as a gate because if the software doesn't deploy correctly, it cannot go to the next gate. After that, we have the integration verification, where we do some manual verification tasks that can't be automated in the continuous integration stage. And finally, after that, we go to the manufacturer release approval, which contains all the rest of the manual regulatory activities, such as product validation, system testing, evaluation, stuff like that. You can see the details in the paper. And here's the model from the paper. I'm not going too deep into the model in here, but in essence, every software change is verified using the same toolings, methods, and processes, and the infrastructure is stored in the version control system, which enables a deterministic way to deliver the software into the target environment. And also we have some technical reliabilities, such as the documentation management, which must be in a version control system or integrated into one. Modern DevOps pipeline toolkits, such as GitLab, GitHub, and comprehensive test automation to reduce the lead time in testing, because manual testing is laborious and takes lots of time. Finally, to the conclusions. So our contributions with this paper: it's a systematic analysis of the standards we selected. Someone might want to use those later. And also our DevOps RegOps pipeline, which reduces the lead time of the software delivery and might enable early customer feedback from the testing phase of the software, because we can now deploy the software into the testing environment, which the customer can already use for testing purposes. And also, the customer may also perform some acceptance testing on the same environment. The pipeline doesn't implement every possible regulatory requirement, but it can be used as part of the overall solution for the regulatory compliance. And finally, we still need some further validation for the model, so it hasn't been implemented fully yet. We have only partial implementations right now. We are planning to do full reference implementation at some point when we have some time. And after that, we can go for real-world use and perhaps even a case study. Thank you.
So, any questions to the speaker?
Hi, at first, thank you for the nice talk. I have one short remark and one question, but they slightly connect to each other. So you say it's reg ops, and the reg is for regularization, regularities. Do you plan to make also some kind of abstraction that it works also for other cases which have also some regulations? Because it sounds like really like on an abstract level that it could be applied at some other stages. And the remark to that, do you mind that it might be a better name to call it reg DevOps, because you already have the dev, so you're not somehow replacing the dev part? I know that just from the biz DevOps, where they just put a business area to the DevOps and just adding that.
Currently, we have no plans for that, so we just took the RegOps term because we wanted to make a regulated DevOps pipeline. Did I answer the question?
Yes, it was a question. If you not plan to abstract it on a high level, then that was the answer.
Yeah.
Further questions?
Hello, thank you for your presentation. Actually, my question is a little bit provocative.
Yeah.
Are you sure that we need the RegOps?
Yes, I think we do.
Yeah, so thanks a lot also from my side. And my question is, I see the value of what you do. Have you gave any thought of how to transform this knowledge into other highly regulated industries, for example, or government institutions, or manufacturing, or other industries that I think they have this need?
Yeah, that's a good question. We haven't thought about that because I think medical devices offer challenge enough for us right now, but that could be future work at some point.
But do you think it's applicable?
No, not directly.
Okay.
Researchers define agile practices as suitable for more dynamic environments, while waterfall and classical methods are more suitable for a static environment. I see that they categorize also medical or critical safety critical systems as static environment, but you choose to develop that with agile. So from your experience, is agile suitable for to be used in such an environment, static environment?
Yeah, I think it's suitable. It has some contradiction because when you read the regulations and the standards, it reminds you of the waterfall model quickly. But there are also some documents that are from the officials, and they can guide you to apply agile software development into the medical device standards, such as Tier 45 from FDA, if I remember correctly.
Thank you. My question is, in your opinion, how much does a specific regulation influence the particular pipeline? So with another regulation, how much is difficult to switch to a new pipeline?
It depends on the requirements that the regulation brings to your pipeline. So manufacturer of medical devices is pretty document-centric. You need good traceability. and you need some specific tooling under the pipeline to like implement the requirements. So it really depends on the like industry field you are trying to apply this. But I'd say yes, you can try to implement one, and I'd say it's possible, but you cannot apply the medical device DevOps pipeline into some other industry directly.
And thank you. I think this closes our official program, and we move to the wrap-up of the conference.
Thank you.
So I'm going to say a couple of words about the PROFES next year. And our plan is to host it in Jyväskylä together with Professor Pekka Abrahamsson. And it will be around the same time of the year, and the weather is going to be almost the same as here yesterday, for those of you who were here already yesterday. So nobody in their right mind would ever come to Jyväskylä in November, but you badasses, you are all welcome to join and then see the whole experience there. Yes. So to come to Jyväskylä, what do? You first fly to Helsinki, and then if you are lucky, there is a flight, and if you are unlucky, you take a train, which because Jyväskylä is about 300 kilometers north from Helsinki. You can also rent a car, but it's going to be dark quite early in the evening. So unless you are I don't know, convenient in driving in the dark, that's also an option. But otherwise, it's 45 minutes by flight and 3.5 hours by train. And I think it will be. I hope it will be over by that time. And then, like I said, I and Pekka will be the co-chairs there. By now, we have set up a website for the call for papers, and the website is being finalized, or it may have been finalized today. CFP will be out early in February, March next year. Deadlines will be by the time you Central European guys come back from your holidays. So it is possible to go on a holiday and then leave the paper for review, and by magic somebody will do the job, and notification of acceptance will come 1 month after that. Camera ready submissions will be then requested in a couple of weeks after the submission. Special features, sponsored discussions are ongoing. We have started this early, and it has been a little bit risky because of the COVID situation, like you mentioned. We aim to have 120 attendees, which of course can be significantly downplayed if we are still in hybrid mode. But we have a bonus because we hope to put the conference in a place where slush will happen. So for those of you who don't know what slush is, it is one of the biggest startup events in Europe. So 25,000 people will come and around 2,000 investors to seek investment. So it is a big event taking place in Helsinki. And chances are that we will fine-tune the dates so that you can go to both events. So the slush is a signed event and PROFES is the main event. Every time we have had a conference in Finland, we have had a strong industry participation, and we anticipate the same. And also fast track with the journal agreement is under works. It has been not agreed yet, but That has been the normal practice in PROFES as far as I remember. Conference venue is going to be Hotel Verso, which is one of the nicest hotels in Jyväskylä area. It has plenty of rooms for hosting the visitors, and it is very conveniently located at probably the most center location you can imagine in Jyväskylä. Truly unforgettable event under the Nordic sky is, of course, the Viking Gala dinner, which will be hosted about 100 meters from the hotel, so you don't have to take a Viking ship to have this. I have been to this restaurant once with Pekka, and the dinner they organize, it's really remarkable. And since we are just announcing this, we are looking for people to play the different roles. So please email me directly or PROFES2022@JUY.fi. And hope to see you all in Jyväskylä next year.
So thank you, Tommy, for this very interesting presentation. So we should start thinking about writing something for coming to next edition of PROFES. I would like to close the conference thanking everybody that helped us to conduct the conference, the reviewers in the first place, all the people that behind the scenes or maybe not so behind managed to make work. So thank you, Simone, for making things work. Thank you also to all of you who came here in presence in Torino. So we hope that it's the first step to come back to normality, maybe next year, and to share, chat and meet people in presence and make connection and networking. I don't know if I think Andreas is online right now. I don't know if he wants to say a final word. Is the man behind the scenes?
Yeah. So thank you very much also from the steering committee of PROFES to Marco and Maurizio, who have organized this year's PROFES mainly as the main people, with many other helping hands around. So it's always important to have volunteers, and therefore I can only support Tommy's request for people who want to help that PROFES will remain a living event, and hopefully next year without COVID restrictions, because it's really a mess. So I also planned to come, but in the end we have strict restrictions in our institute regarding traveling, and therefore it was not possible. So thank you, Marco, for doing that, for also trying to keep the event as a live event, and finally you had some people there, even if the number is low, but it's a good sign for the community that people are willing to attend conferences, and that the virtual thing is not in the end the solution. So it's really important, the exchange between the people. So thanks again to all of you, the authors, the reviewers, and the organizing committee.
Thanks to the steering committee, to Andreas particularly for supporting. And I remind you all here that we have still the dinner this evening later. Yes, essentially in a couple of hours. See you for the dinner, and see you all the people remotely next year in Finland.
Okay.
Bye.
Thank you, Marco.